explain Coriolis force? My dear friend, that time will come. Please don't get impatient. We will cover that. So, hello, a very warm good evening to all of you, and welcome to Byjus Exam Prep IAS. Welcome to another session of geography, which shall be our final session for geomorphology. And in this portion, we are going to cover the various different landforms which are created on the surface by the exogenic forces acting on the planet. So here in this particular chapter, we are going to deal with the basics when we talk about what do we understand by landslides or mass wasting. We are going to understand how is it that the rivers end up creating distinct kind of landforms that you and I we encounter on a regular basis, but we are not able to make much sense of it. The landforms created as a result of glacial movement, wind action, sea wave action, all of those we are going to study. Now, in all of these, you will find a basic commonality, be it the landform created by a river, be it a landform created by a glacier, or an action of, let's suppose, the wind or a sea wave, or even at the region of underground landforms which are created due to water. Now, in all of these, you'll find the common factor that it is the forces from the outside of surface which are acting there. So these are what we will be studying under exogenic forces. So till now, what we have studied and what we have been studying for the past week and a half almost is basically concentrating upon the forces which are erupting and emerging from inside the Earth's surface, which are initiated in the region of the interior of the planet, and then they end up having their impact on the surface of the planet. And there we exposed ourselves to the various different endogenic forces. So today we shall be directing our attention to the exogenic forces. Now, this is a portion which is relevant both for your prelims as well as for your mains examination. In the prelims, what kind of questions do you expect from here? So here you will get a question associated with, let's say, when we talk about the landforms, then their types, okay, weather, and also the agent of nature responsible for creation of those landforms. Also, basics of mass movement. Okay, that is what induces the mass movements. Whereas, when we talk about the portion for mains, now here also you will get questions about erosional and depositional landform, basics of mass movement. And there, combined with the portion of Indian geography. That is where the questions are basically crafted from. So here in this particular portion, we shall be introducing ourselves. For example, what do we understand by a landslide? Why a landslide is actually induced in a particular region. And then actually, if you take a look at the questions which are asked in the examination, they will be more or less directed towards the Indian geography portion. For example, why is it that the Himalayan region experiences more landslides as compared to the Western Ghats region? So that is where the comparative analysis will be required out of you. So here, once we introduce ourselves, then a greater amount of conceptual clarity and a greater amount of differentiation we will be doing when we are covering the portion of India's physiographic divisions. So combined with Indian geography. Okay. So that is how this particular portion is relevant for your exam. At the end of this particular PPT, we shall also be taking up for discussion few of the areas or the few of the type of subjective questions which have appeared from this particular region. In the portion of PYQ discussion, we shall be discussing the portions which have been asked in geomorphology. Okay. Gadamidi, we want written PPT. So have you taken a look at the portion of additional reading materials? Please let me know. Gadamidi, have you taken a look at additional reading materials at all, ever? I think not. Yeah, that is why. So kindly take a look at additional reading material. All the written text that you are searching for, that written text is present in the additional reading material. So take a look at the additional reading material, and that you have to complement along with the PPT, along with the current affairs. Okay. So the written text that you are seeking, that you are searching for, you will get in the NCRTs or you will get in the additional reading materials. So please open up that particular document. That document is not there to lie in a kind of a folder on your system or your laptop. That is for your utilization. Please do that. Gurjeet, we have covered tsunami already when we were covering about the portion of earthquakes. Kindly look at the recordings. You will find that we have covered how is it that the tsunami comes into existence, why is it that the tsunamis are created. We have covered that. Mantle plumes we have covered yesterday, isn't it? We have covered mantle plumes yesterday. Okay. Are the ARM and the notes with annotations or a separate PPT? Notes with the PPT with annotations is a very different thing. Additional reading material, when we say, these are the additional things that you need to be covering or that you can always augment your sources of information from. So that is why take a look at those additional reading materials. Okay. Tsunami has been covered while we were discussing about the portion of earthquakes, and while we were discussing about the global distribution of earthquakes. Just before that topic, we have had a discussion about tsunami. Okay, right? In normal fault, why land move downward or upward only? Why not land? Because there is a tensional force. If there is a tensional force, how can a land move in a sideway manner? Land will either move up or down in that case as you pull. So if you pull this apart, will the if I break this pen, will the pen move towards you? No, it will either adjust itself upwards or downwards, isn't it? So apply your logic, please. So here in this area also covered desert. Why will we cover desert here? What do you want to cover in the portion of desert? Formation of a desert, is it that something that you want to cover, or do you want to know more about Thar desert? Always understand that we are talking about, when we talk about deserts, so here I have given you certain map pointings for the desert to expose you to the various different deserts which are present in the world. Now about that, more that you need to understand is why there is a desert formation, isn't it? How is it that a desert are created? I hope that is what you want to understand. So that is what you will be studying in the portion of climatology and oceanography. Having said that, now let us come into the portion of landforms, erosional and depositional. So till now, we have been studying the portion we have been studying the various different portions of Earth's movement, the different types of compressional, tensional forces which are experienced by the Earth's surface, and that leads to different kinds of landform, fold, faults, all of that we have taken a look into, earthquake occurrences as well as volcanic eruptions. Those are the things that we have taken a look into. Now here, when we talk about what are the or how is it that these forces are induced, they are the forces which are induced from the interior of the Earth due to some or the other events happening in the interior of the Earth. That is why those forces happen, and that is why the planet experiences those. You have the classification of forces: sudden forces, diastrophic forces. Then within diastrophic forces, you have Epeirogenic, orogenic forces. We'll take a look at that as well briefly. But the forces acting from the interior of the surface, They are referred to as endogenic, coming from inside. Then we also have certain number of forces which act from the outside, which are acting on the surface of the planet. For example, the action of the rivers, the blowing of the wind, the movement of the glacier, the movement of the sea waves. Now, those forces which are acting from the surface, on the surface rather, they are referred to as exogenic forces. So, while we have covered the portion of endogenic forces in significant detail, now we will be talking about the exogenic forces today. And with that, we are going to address the various different landforms which are created. Broadly, you will observe that all the various different types of influences that you have on the Earth's surface, they are either a product of the endogenic forces or the exogenic. Exogenic refers to forces acting from the outside. Acting from the outside. Whereas these are forces acting from the interior. Acting from the interior. Okay. Now here, while we have studied the endogenic forces in itself is basically classified into sudden forces and also what is referred to as a diastrophism or slow acting forces. Slow acting forces or processes. Now, when we talk about sudden forces, for example, earthquakes or volcanic eruption, they end up happening all of a sudden, isn't it? It is not as if an earthquake has been occurring over a particular region in India for the past 200 years. Every day there is a slight shaking and continuously it is shaking up like this topsy-turvy shaking is happening. It happens all of a sudden whenever it happens. So is the case in the case of volcanoes also. They will happen all of a sudden at one instance at one point of time. Whereas when we say diastrophism or diastrophic forces, these are basically the very slow acting forces which will enact themselves over a period of maybe hundreds of thousands of years, maybe even millions of years, hundreds of millions of years, and so on. Now, these are also what are referred to as the continent building forces or mountain building forces, so to say. We will study about the basics of what are the two types of diastrophic forces as well. But when we talk about exogenic, one of the part of exogenic forces, the erosion and deposition. What is erosion? Erosion is basically comprised of or the process where some part of an existing material is removed from there. Let's suppose you have a particular rock here, let's suppose, and on top of that rock, there is a river which is moving from there. Now, every moment, every day, the river will carry some particle of that rock along with it. The river will be carrying some part of that material along with it. And the portion of the rock, the size of the rock will keep on reducing. That is erosion, right? But all the materials that the river is carrying, it will deposit it eventually somewhere, isn't it? So that is deposition. So this is what is also referred to as gradation process or the process of gradation. Now this is carried out by the exogenic factors, maybe river, maybe wind movement, maybe the sea waves, or maybe even by the action of glaciers. Now, first of all, what do we understand by diastrophism? Even though we have introduced ourselves to this, we have taken a look at the impact that the diastrophism creates, but what exactly is it that we refer to as diastrophism? So it is the process of deformation that changes the Earth's surface. It produces many of the basic structures that we see on the surface, such as plateaus, mountains, and folds in the crust. Now, diastrophism basically initiates a kind of a movement. That movement is largely horizontal. It can bring about a tension, it can bring about a compression, Whenever compressional force is brought about, there is a kind of a fold creation or there can be a fault creation. Compression leads to which kind of fault? Let me know. Let me see if we have any retention of what we have covered yesterday. Compressional forces lead to which kind of fault creation? Very good. Reverse fault. So reverse fault is created when there is a compression or there will be a fold which is created. So that horizontal movement of tension and compression, that is included in the portion of diastrophism. But it is not only that. Remember, while discussing about the portion of convection current theory in itself, we have had a discussion about the fact that when we talk about the Earth's surface experiences heat coming from inside, and that is the residual heat. And that heat can lead to the upliftment of the land and also the subsidence of land in certain cases. So there is also sometimes the vertical movement which can be initiated by the endogenic forces or the diastrophism. So diastrophism overall includes horizontal forces, and these will include tensional and compressional force, and also vertical forces, which basically will consist of upliftment and subsidence of land. Okay. When we say an upliftment of a land or subsidence of a land, what do we mean by that? So, in order to help you visualize, let us think about a scenario. Let us think about a scenario where, let's suppose, the landmass is somewhat like this. Okay. Let's suppose this is the landmass, a large landmass spreading across thousands of kilometers, let's suppose. Now, it might happen that there is a significant amount of endogenic force happening in this area. Endogenic forces acting in this particular region. Now, that can lead to an upliftment sometimes. And that would mean maybe on a daily basis, maybe on an yearly basis, or maybe on a basis of every 100 or 1,000 years, there is some upliftment. Now, this rate of upliftment which will happen will be really, really slow. Something that you and I, we cannot gauge with our everyday observation and with the normal perspective. So you will observe that on a daily basis, maybe it has been uplifted by 1 centimeter. Again, maybe by, or maybe 1 centimeter, I'm talking about maybe in 10 years or 20 years. Maybe on an yearly basis, it rises by 1 millimeter or something like that. So it is a very, very slow process. And after hundreds of thousands of years, you might come across a landmass which very well might indicate the creation or the formation of a plateau-like structure where it is significantly elevated. Okay. So that is your vertical movement, which is initiated and it is a slow process. So this vertical movement is what is categorized as a kind of a force which we refer to as Epeirogenic force. Okay, so diastrophism is classified into two types. One is what is referred to as Epeirogenic, another is what is referred to as orogenic. Epeirogenic, another is what is referred to as orogenic. Epeirogenic is what leads to a kind of a vertical rise and fall. Whereas orography, orogenic, whenever you encounter this term, orogeny, orographic, anything, always it has got to do something with the mountain, right? So orogenic forces are those horizontal forces which end up creating faults and faults. Okay, so here when we talk about epeirogenic, they correlate to the vertical upliftment or subsidence of a large mass of land. So this leads to vertical movement of land. And this has happened, guys. It is not as if it is such a rare circumstance or such a rare phenomena that we never get to experience that. Even in India, there are certain places which geographically, and when you talk about the geological history of that place, that has not always lied at the sea level. But then there has been an increase in height. For example, the region of Chota Nagpur Plateau, in the region around eastern part of West Bengal, Jharkhand, some parts of Odisha. Now, that Chota Nagpur Plateau is such an old landmass that it has gone through multiple different phases of upliftment and then subsidence, upliftment and then maybe subsidence after that. And every time that this process takes place, it spans for millions of years, many, many millions of years, where the rate of upliftment will be maybe 1 centimeter every 100 years. Something not even discernible with the common perception or the common observation. And then here you have the case of mountain formation. Mountain formation. That is by horizontal movement. Now, so epeirogenic is the endogenic force which leads to upliftment or subsidence of the landmass. And then orogenic is mountain forming forces. Now here, mountain building forces or orogenic forces can be classified into two types, folding and faulting. Both of them we have studied. Now, folding ends up creating fold mountains. Example of fold mountains: Himalayas, Alps, Andes, Rockies, Atlas. Which is the latest fold mountain to be created? Very good, Manas. Which is the latest fold mountain to be created? Yes, Aravalis will also be a fold mountain. We have had a discussion about it, that the youngest fold mountains which have been created, I had given it to you as map pointing, and it is not Himalayas. Good, Brundavani. Very good. Kambhapati correct. Priyadarshini correct. Abhijit and Pooja correct. It is basically the coastal Cascade ranges that you find to the west of the Rocky Mountains in the western part of North America. That has been created only around 1 or 2 million years back. So that is your example of one of the latest fold mountains which have been created. Shivaliks, their formation was initiated close to around 15 million years back. So Shivalik, while they are overall, if you consider all the mountain systems, yes, Shivalik will be amongst the younger mountains, but it is not amongst the youngest. Then faulting. Faulting, can it create a mountain? If yes, can we have an example of which kind of mountain is created by faulting? Let me see. Block mountain. Very good. Block mountains. Example, Vindhyas, Vosges. These are your, even Drakensberg in the region of South Africa. That is also an example of an escarpment overall. Now, this is how folding and faulting can lead to the formation of a mountain, and how epeirogenic forces can lead to the rise of a landmass, can lead to the fall of a landmass or subsidence of a landmass as well. So that is what is included in the portion of endogenic forces. So endogenic forces are driven by what? They are driven by the residual heat present in the interior of the planet. Driven by residual heat present in the interior. Whereas when we talk about the exogenic forces and processes, they will be initiated by outside factors. Generally, even if you talk about the glacial movement, wind movement, etc., that will have a direct or an indirect implication with the climatic condition, with the factor of the solar insolation, the solar light, the solar radiation which is coming in. All of them will have their own contributory impact there. Now here, if you take the case of it, tensional forces, I hope we understand the meaning of tension. What is the meaning of tension? Anything which is getting pulled, right? So tensional force is the pulling force. You have the force in opposite direction which is acting. Orogenic leads to epeirogenic movements, not always. Weber, no, not always. Okay. So I hope, Vivek, that is understood. No, San Andreas is a kind of a fault, but it is not a kind of a mountain. So faulting can lead to the formation of various different cracks, but then we are talking about the orogenic or mountain formation there. So when we talk about the exogenic forces, they act on the surface from the exterior. They can further be subclassified into weathering, mass movement, and erosion and deposition. Let us analyze them. So weathering. What is weathering? Weathering is when any existent rock is actually broken down and it gets disintegrated into multiple smaller pieces without getting transported anywhere in the same region. It gets broken and disintegrates into multiple smaller pieces. How? By the chemical action, physical action, as well as biological action. What do we mean by mass movement? Mass movement basically refers to that effect where, due to the action of, let's say, a presence of a slope or a kind of a gradient, presence of excess amount of volume of water. Now, due to that, if there is a kind of a motion in bulk, large amount of material, soil, rocks, everything, trees included, everything slides down the slope or falls down the slope. We say that the mass is moving or movement is happening in large mass. And then you also have the erosion and deposition process. All of them are acting on the outside. So first of all, let us talk about what do we understand by weathering. Then we will try to understand what is meant by mass movement. And then we will go into the portion of gradation or erosion and deposition. So weathering. Weathering is, by the way, a term that is also used in English language on a day-to-day parlance, where you talk about that due to that rigors of preparation, that individual was weathered down. Means there has been a significant erosion or significance uh, impact on that particular individual. So when we say weathering, it is a natural phenomena whereby a particular rock gets disintegrated into many small parts, either due to physical, chemical, or biological action. So here, an existent surface or rock, existent surface or rock gets disintegrated into smaller parts due to physical, chemical, or biological actions. In fact, for that matter, when you will observe, or when you observe the presence of soil particles around you, when you walk out of your house and you observe the soil and the sand simply strewn around on the surface, where do you think that soil has come from? Is it that soil also has been created by God? When God created such a beautiful planet, God also provided some space for the soil? No, it is basically the rocks. At one point of time, there was no soil. In any newly created landmass, there is no soil. So, soil is created also in a span of millions of years by the disintegration of the rocks. The existing rocks, they get broken into smaller parts, further broken into multiple smaller parts, and this process continues till you have the fine grains of soil and sand. That is why everybody talks about the conservation of soil, because that soil has the soil which gets eroded and which we simply don't care about. That soil has taken millions of years to attain the formation, and that is why conservation is very, very important, right? So here, let us understand how is it that a physical, chemical, or a biological process can lead to disintegration of a rock. And when we say a disintegration of a rock, so let's suppose large area or a large rock. Now that large rock initially will get broken into smaller fragments, multiple smaller ones, and that is how eventually these small parts, they will get broken, and then the remaining will get broken, and it carries on. So first of all, let us try to understand what do we mean by physical weathering. Physical weathering means what? Actions which weaken the physical structure of the rock surface. So for example, let's suppose you have a particular kind of a rock, and try to understand it, try to visualize it here itself so that it is clear for perpetuity. So when we talk about a particular kind of a rock, let's suppose it is kept in a region where the winters are very, very cold, summers are hotter. So in such an area, let's suppose due to immense amount of heating, the rocks will expand, isn't it? Any material, when it is heated significantly, rocks, they will expand. And if ever you have walked barefoot on a rock, I'm sure all of us would have done that at some point or the other in our lives. If we have not experienced that, then again I would say it is high time, high point in your life, that you experience these basic things of nature when you walk barefoot on a larger rock. Now in that case, during the daytime, nobody even dares to do so during when the sun is shining. Why? Because the rocks become very, very hot, isn't it? So I'm sure all of you would have seen that or observed that. So during the day, when you have the sun which is shining brightly, the rocks will get heated. Now let's suppose throughout the summer season, a particular region has experienced a lot of heat. So the rocks will expand ever so slightly, maybe by a few millimeters, maybe by a couple of centimeters at max, but it will expand ever so slightly. Now, if the winters are very cold, maybe 0 degree, -1 degree, etc., then there will be some amount of contraction. All the materials contract when they get cold. So the rocks will contract. Again in the summers they will expand, again in the winters they will contract. Now this is a kind of a expansion and contraction where the structure of the rock in itself sometimes gets weakened. And due to that weakening of the structure, you have the development of a kind of, let's suppose, a crack. Let's suppose a crack appears. Now, if we consider that there is rainfall in the region, now that rainwater will percolate, will penetrate this crack, will fill up this crack. That rainwater will fill up this crack. Now, during the winter season, when the temperatures go low, now this water which is present, that will freeze. And what will happen to the crack? When this water gets converted into ice, what will happen to the crack? Will the crack size remain the same? Will it contract or will it expand? What do you think? Very good. The cracks will expand, isn't it? The cracks will tend to expand. Why? Because ice is a larger form of water. Ice is an expanded form of water. So the cracks, they will expand. They will widen, right? Again, during the summer season, again it will melt more rainwater. Again, during the winter season, maybe it will expand. So this process continues for hundreds, thousands, and millions of years. And eventually, after that, what you will observe is that this crack deepens significantly, and eventually, what do you have? The rock will break into two. Now, this breakage of rocks is initiated by the physical agents of the nature: sunshine, temperature, right? A presence of rainwater. So whether you heat the rocks, it will expand slightly. You cool them, it will contract slightly. The rainwater will help to enable the widening of the cracks also. So that is what is physical weathering, where the physical agents of the nature are involved. That is what is physical weathering. Now here, when we talk about, let's suppose, the chemical weathering, let's understand what do we mean by chemical weathering. So again, here, when we talk about chemical weathering, this is initiated when you have the materials which are in water. Only in that case will the chemical weathering be initiated. Let's suppose this rock has the presence of a certain material such as calcium. Calcium is readily soluble. So let's suppose here you have significant chunk of calcium. Let's suppose here you have calcium. Why calcium? Because calcium is soluble in water. Now, we have already seen that how basically with the heating, cooling of the rock, the size keeps on changing continuously. That might lead to the structural failure of the rock where there might be development of a crack. So let's inherit that particular piece of information where there has been the formation and development of a crack in the rock because of subsequent heating and cooling which has been happening through the various seasons. Now, after that, if there is rainfall, significant amount of rainfall which occurs. Now, what will that rainfall do? That rainwater will start percolating through here into these cracks, right? They will dissolve this calcium. It will form a kind of a pool. Eventually, all that matter will be dissolved by water because calcium is present and calcium is something which is soluble in water. And eventually, as this process continues, within a few years or few hundred of years or few thousands of years, depending upon the size of the rock, now it might happen that this entire portion gets dissolved and gets removed. Now, from this rock, if you remove this larger portion, will the rock be able to maintain its structural integrity? No, the rock will break. So here the breakage of the rock is initiated by what? That is initiated by the chemical process of solution, where the materials of the rock, they get dissolved in the water. So here, materials of the rock get dissolved in rain or seawater forming a solution. That solution drains away. And what had earlier formed the rock, now there is a gap there. How much time will it take for this solution to happen? That depends upon how much amount of material is present to be dissolved. That depends on the size of the rock as well. So while it can take a few years or a few decades, it can also end up taking few hundreds of years, few thousands of years, or even in certain cases few millions of years. Okay, so it is a very slow acting process, it is a long term process. Now then we also have what is referred to as biological weathering. Now, what is that case of biological weathering? Let us try to understand that. So, biological weathering, here the events and the actions of the living species that comes into play. How? So, anyways, many of the times in your life also you would have encountered when you go to visit or wherever you are traveling, if you visit any old government houses, very old residential properties where nobody lives right now, or old buildings which is now abandoned, you would have observed sometimes that there are small plants and saplings which are coming out of the walls and the roofs. I'm sure all of you would have observed that there is a small plant, there is a small twig which is coming out in between the various different walls, right? Almost all the governmental residences that you have, you will find that if you are one of those individuals who lives in a government quarter, you will find it in your own locality that there are many such houses having some or the other shoot of the plant originating from some region or the other, right? Yes, good. So you have your personal experiences as well. So basically what happens in that case, so let's suppose here you have an existing rock type. Let's suppose. Now, in this existing rock type, as is the case, and this rock that I'm talking about, this can be very large. Don't think or compare it with a small stone that you find it on the side of the rock. This can even be for a few hundred meters, maybe a kilometer wide as well. So I'm talking about very large rocks. So let's suppose here there is a kind of a crack. Now, in this crack, you will observe that a plant grows. Why will the plant grow here? Because the roots, they are getting access to the minerals of the rocks. They are getting access to moisture also by rainfall. Now these roots, they will try to spread, they will try to grow. Now after they have spread themselves, maybe another plant grows here, right? It will also have the roots which will try to expand. Now maybe a small rodent like a mice or a rat or maybe few insects, the burrowing ones, they come here and they start digging burrows. So they will further deepen this. They will further end up deepening this, isn't it? Eventually, let's suppose that space is utilized by another set of plant. Eventually, what will happen? The cracks get enlarged. Multiple species will start living there, from lizards to snakes to maybe mice, rats, everything will start living there. And eventually, the rock will break. So, why has the rock broken here? Because of biological agents, because of the biological functionality. So, that is what is referred to as biological weathering. So the breaking of the rocks can happen due to the physical agents, the physical forces, can happen due to the chemical forces, or can also be initiated by the biological processes. Now, if I ask you a question, now basically in the case of biological weathering, many of you would have seen that, all of you who said that yes, you have observed the walls with certain plants coming up amongst these walls here and there, you would have observed that those walls develop a crack over a period of time unless and until the plant is immediately uprooted and taken care of. Those walls develop a crack, and that crack continues to deepen. It deepens quite significantly, isn't it? So that is the biological weathering. Now, if I ask you a question, that this physical weathering, biological weathering, or chemical weathering, can they happen all at once, or will they happen individually? That here physical weathering is taking place, so no chemical weathering. Here chemical weathering is taking place, so no biological weathering. Can they happen all at once, or will they happen independently? Perfect. Perfect. So basically, out there in the nature, all these events of weathering, they happen simultaneously. They happen at the same time. That the physical weathering weakens the rock structure, creates cracks through which the plants will grow. The plants will also secrete certain substances which will dissolve certain materials of the rocks, leading to chemical weathering, and that will further enhance the breakage of the rocks. So, out there in the nature, in practical scenario, all of them can be initiated or is initiated at the same time. Okay. Now, any doubts that we have till now? Let me know. So, no doubts? Good. Now, physical weathering. Physical weathering is when the agents of the nature, such as heating, cooling, etc., expansion, contraction of the rock, that leads to the development of cracks. Why all of these happen? These will happen because the rocks are exposed to external circumstances. The rocks which are present out there, they are exposed to external circumstances of sunlight. So when there is significant amount of heating, any material will expand. When there is substantial amount of cooling, any material will contract, isn't it? Right? Carbonation, oxidation, and reduction. Vikram, I think you have received a written reply for that, isn't it? I think you have received a written reply. So basically, when we talk about carbonation, just to simplify it for you, or oxidation in general, oxidation is what? When an oxide is created. Whenever an oxide is created, where oxygen from the air that combines, so it forms an oxide which becomes weaker. Reduction is the process of deoxidation. So these are also the chemical reactions. All of these are chemical reactions which happen. So when I say the formation of a solution, this is talking about in simplistic terms about how the solution is formed. So the solution will be formed in multiple methods, or the chemical reaction will be induced by multiple methodologies. There can be an oxidation, there can be a reduction, there can be formation of a carbonate ion. What is a carbonate ion? Where you have the materials interacting with carbon dioxide in the atmosphere, so carbonation will be observed, isn't it? So all these are chemical actions. And is just breaking of rock enough to get soil sediments? Yes, multiple such breaking events that will lead to the soil formation. Are wind and water physical agents of weathering? Yes. Can we say physical and biological weathering are almost same? No. Factors of weathering, when we talk about, you can have physical agents, chemical processes, materials, chemical agents such as rainwater, salty nature of seawater, acidity in rainwater, biological agents, all of them. How will it become hot by expansion of rock? I don't understand. What will become hot by expansion of rock? The rock, when they get hotter, that is when they will expand, not the vice versa. When the rocks they get heated, what will happen? It will tend to expand. Okay, so that is where the expansion, contraction, everything is happening. Okay, now can we consider karst phenomena as weathering? Yes. Weathering create which type of formation? Smaller rock formation. Freeze thaw. Freezing is when something freezes, thawing is when it melts or when it breaks. Janvi, no, physical weathering is basically something initiated by the physical action or the physical agents of the nature. But then, as I told you, that physical, chemical, and biological weathering, all of them, they basically can happen at the same time. They occur simultaneously. Frost wedging. What is frost wedging? Okay. Clearly, you are taking a look at the topics from somewhere and you are simply putting up the questions without understanding what is being taught in the class. So, understand this again. I will repeat it again. So, pay attention here. When we talk about what is a wedge? Drawing a wedge. What do we mean by drawing a wedge? Again, all these are English terminologies, my dear friends. So when we talk about drawing a wedge, you are separating something. What is a frost? Something which gets frozen. So let's suppose in a particular crack there is water which has accumulated. Now when it will freeze, it will expand the crack, because ice is an expanded form of water. Then again more water will accumulate, then more it will freeze, then more the crack will expand. So in a way, what you are doing, you are increasing the wedge, isn't it? That will lead to the breakage of the rock. Is that understood now? I hope that is clear, Vikram. Right? Can man or animal activities be included in biological? Not so much. Man made activities, we don't carry out weathering process immediately. Weathering will lead to metamorphism of land. No, not so much. Okay. From where did exogenic processes get that ultimate energy? Sunshine. Right? Now, after this, we move ahead to the portion of mass wasting, which is also referred to as mass movement. This is also what is referred to as mass movement. Where you have a bulk movement or movement in large quantums of materials which are present, they start moving in large quantities. So that is what is referred to as mass movement or mass wasting. So when is it? So suppose if in any particular region, the materials, there is a lot of loose soil without any kind of a plant, lot of loose soil, let's suppose, is present here. Now, if we have a plain surface, will that region ever experience the movement in significance? No, there won't be significant amount of movement. But when we talk about the same condition in a sloping area, let's suppose, lot of loose soil and let's say sediments, rocks, etc. Now here, this will try to move. Even if there is slightest amount of rainfall, that rainwater will dissolve many of them or bring all of them, and they will start moving, isn't it? That is where on the slopes of the hills you will observe a large scale movement. Now let's suppose you have a condition where the slope is somewhat like this, a steep slope, almost vertical. Now, in this case, if there is a rock structure which is overhanging like this, now for this rock structure, automatically, slowly and steadily, it will get weakened and it will fall down. For that, you don't need any agent of nature to be helping. Maybe solar light and solar heat will lead to expansion, contraction, and weathering, and then it will break down, isn't it? Now, in both these cases, what is a common factor? The common factor is the influence of gravity. That influence of gravity is very significant, is very important. So when you have a large scale movement of rocks, loose materials, soil particles, etc., under the influence of gravity, large scale movement, not that one rock simply comes down rolling, large scale movement, that is what is referred to as mass movement or mass wasting. So gravity has got a very substantial role to play here. Now, this mass movement, depending upon how that is happening, whether it is happening across a vertical section of the wall, or whether there is too much of water present, or let's say the land in itself has basically subsided as it is slipping over. So you have different types of mass movement. They are also classified into different types. So here you have the slide, flow, and fall. Slide means materials will start slipping and sliding under the influence of gravity. Then you have flow, where you have, what do we mean when we say flow? Some amount of fluidity, behavior like a liquid. So that will be included in flow. And when we talk about a fall, so maybe on top of a mountain cliff, materials they start to fall, right? So slide, flow, and fall. That is the major classification. So then under that you have earth slide, mud slide, landslide. Even in flow, you have earth flow, mud flow. Then in fall, you have debris fall, rock fall. So that is basically the categorization depending upon what is the amount of the controlling factors, or what is the contribution of the various contributing factors. So what are the contributing factors which determines what kind of mass movement will happen, or whether the mass movement will happen or not, or what will be the speed of the mass movement? So those contributing factors are the volume of material. And when we say volume of material, yes, this will also include a creep. Many of the times creep, because it is so very slow, it is not categorized separately. So when we say volume of material, it is availability of loose materials which can move. Okay, availability of loose materials which can move. So in any particular area, in any particular slope, let's suppose you have lots of various different rock fragments which are free to move. So automatically with the slightest of trigger, all of them will start rolling down. That is why when you have steep slopes and overhanging rocks, lot of materials which can fall, they automatically start dropping down. So that is the contributing factor of volume of material. Then you have the water content. Now, if there is a greater amount of water available, and what water content are we talking about? So this water is made available by the flow of the rivers and the streams down the slopes, and also by the availability of rainfall. So both of them will contribute to the water content here. So in a particular slope where you have a lot of loose soil and a lot of loose materials, if there is excessive amount of rainfall, what will happen? Materials, they will start sliding down. Mixed with water, they will gain a kind of a muddy feature. They will generate a lot of mud and they will start sliding down. Maybe they develop a flow like a liquid. That is what you refer to as the mud flow. If they consist of all the various different types of rocks also along with them, that is what will be referred to as the earth flow. And if they consist of tiny fragments, etc., debris flow. So the volume of water which is available, if it is greater, mass movement will always happen. If the volume of water is less, even the speed of mass movement will be lesser. So water content is directly in a way proportional to speed of mass movement. The speed of mass movement that you have, that is contributed by the water content. Okay. Then you have the steepness of the slope. Greater the steepness of the slope. When we say steepness of the slope, what do we mean by that? This is referred to as a gentle slope. This is referred to as a steep slope. So if the slope is very, very steep, what will happen to the speed of mass movement? Speed will always be greater, isn't it? So if the slope is steep, movement is faster and also larger. You will have larger amount of materials which will start moving down, which will start sliding down maybe. So steepness of a slope is also a contributing factor. Now, having said that, let us take a look at few of the examples of mass movement to understand the characteristic better. So here you will find three images on your screen. The first image is something that we oftentimes are made aware of when we take a look at the newspaper or the news headlines during the rainy season. This is a factor that we are very, very well aware of, and that is a landslide. So here in this first image, I want you to observe here that how this entire region has basically simply slid down the mountain slope. Now, when will this happen? For this, availability of water needs to be high or low? What do you think? Availability of water for this? Very good, high. The gradient needs to be high or the gradient needs to be gentle? What do you think? Very good. Volume of material which is available to flow, that or available to move, that needs to be high or low? Very good. So when you have the slope also which is slightly steeper, see, if the slope is almost vertical, there is no need for this slide, automatically it will start falling, so that is what is categorized as a fall. But when the slope has got significant amount of gradient, it is steeper and lot of water is present, and there is loose materials which are available, materials will automatically start sliding down the slope because the gravitational force is active. So here you need basically higher availability of water, steep slope, and lot of loose materials which can move. Okay, which can move. That is why whenever there is a landslide, in India, landslides are mostly observed either in the Himalayan stretches or in the region of the Western Ghats. That is where landslides are a commonality during the rainy season, particularly. Rarely will you come across a landslide event during the winter, or rarely will you come across a landslide incident during the peak of the summer. You will always encounter it when there is rainfall, when there is heavy amount of rainfall. And why is that? It is because that is when the water availability is made available or is maximum. Now, also you have to understand, wherever there's a lot of loose soil, that means there is lack of tree cover. Trees, they have deeper roots. They bind the soil in its place. But if you don't have significant tree cover, the soil is free to move. So in the slightest amount of rainfall, the soil starts moving away. And you have massive disasters and massive casualties which are created. That is why slope stabilization is done. And what is that slope stabilization? Where you find that wherever there are loose materials, automatically before the rainy season, they are taken care of. They are basically forcibly brought down so that when the rains come, then these don't slide anymore. Or if let's suppose there are a lot of loose materials, you cement it in the place or you bind that in the place so that it doesn't drain easily, it doesn't move easily, right? If ever you get an opportunity and to travel by rail in the region of Railways, I hope you are aware, is one of the engineering marvels of our country. The route that it takes is simply breathtaking and also is a testament of the engineering marvel where we have constructed the railway line through all those dangerous regions or the sloping regions. So if ever you end up traveling or you get an opportunity to avail a travel in the Konkan railways, you should always take that. As you travel there, you will observe that there are very, very steep slopes. But then all those steep slopes, they are held very tightly together by a wire mesh. There's a kind of a cage of wires which holds the rocks and those materials in its place. The steel mesh. Now that is to prevent what? An accidental slide or falling of the rock or the debris materials, to keep the railway line free of those interruptions. So that is basically what leads to landslides. Then you have here the creep. Now, creep is what? Creep, basically, when we say that, you use it in English parlance that that person has creeped up or the water has creeped up to this level. Whenever you have a very slow movement, very slow movement. So many of the times you would have observed that, for example, in any particular region where the slope is not very significant, it is very slight, you would have observed that all the telephone lines in that region, they indicate a bend in the same direction. Or maybe the fencing that someone has carried, all the various pillars of that fence, they are bending ever so slightly in the same direction. I'm not talking about the telephone poles which have completely broken down. That is not due to creep. That is because of administrative negligence. I'm not talking about those cases. I'm talking about where you observe the telephone poles and in certain cases, even the trees, where all of them, they indicate a bend in the same direction. Slightly they are bent. That is indicative of creep. Creep is a very slow movement which happens. Observe here. Here also, you will observe all of them are bending. Now, why does this happen or when does this happen? It happens when you have a gentle slope, then very low availability of water, okay? So in those cases, a very slow movement is initiated, where the soil in itself encompasses a kind of a slow movement. Something again not perceivable by the naked eye, something that you can observe after a long point of time, where you observe that yes, indeed, on a daily basis, on a monthly basis, maybe there is some movement and the fences may be bending ever so slightly, but it is something which is visually perceivable after a long period of time. That is a slow movement, which we refer to as a creep. Then we have another very interesting kind, which either you observe in very high altitudes or in very high latitudes, that is closer to the polar region. That is where it is very common. And that is what is referred to as solifluction. Now, what is this solifluction? In the case of solifluction, here the topsoil starts behaving like a fluid. Why and how? So this is observed generally in the region of permafrost. Observed generally in the region of permafrost. What is the meaning of permafrost? A region which is permanently frozen, where throughout the year you will find that at least the subsoil or the lower regions of the soil, they are permanently frozen. Okay, that is a permafrost. So in those regions, the subsoil is permanently in a frozen state. That is something you will find. So in these regions, subsoil is permanently frozen. Even the top portion is frozen during the winter months, but many of the times during the summer months, the top portion defreezes. Now, when the top portion has actually defreezed, it has returned to its non-frozen state. Now, the topsoil is not in a frozen state, the subsoil is still in a frozen state. So, will the topsoil retain its connect and contact with the lower layers, or will there be a disconnect between the top and the lower layers? What do you think? Obviously, there will be a kind of a disconnect, isn't it? The top layer is free from freezing, whereas the bottom layer is still frozen. So, there will be a kind of a disconnect. In that eventuality, even if there is a slightest amount of moisture, the top thin layer of the soil develops a kind of a fluidic property. And if you observe this image, you will observe that the soil in itself develops a kind of a flow pattern where it behaves like a fluidic portion or a fluidic material. Observe this image carefully. So this is where the topsoil gets disconnected with the bottom layer, and in the presence of moisture, water, melt water, anything, the topsoil starts to flow. Okay, so topsoil gets disconnected in the presence of water, it develops a flow, and that is what we refer to as solifluction. So why I have taken the case of these three types is because in all the three examples, or with the help of the three examples, you will be able to appreciate that how, depending upon the slope characteristic, depending upon the availability of water, depending upon the volume of material, now you have the movement of large scale of materials. Now, that movement can be a slow speed movement like a creep, fast movement like a fall, where immediately it starts falling almost vertically, or a slide or a flow. Okay. However, I'll give you the aspects, the written aspect of landslide, something which is very common. That is defined as the movement of a mass of rock, debris, or earth down the slope. They can be initiated in slopes already on the verge of movement by rainfall, snow melt, changes in the water level, stream erosion, that is impact of the river or the streams moving through that region, changes in groundwater, earthquake, volcanic activity, anything, even human activities, they can end up initiating a landslide. Earthquake and shaking of the ground surface, they can also end up initiating landslide. Okay. Now, Harsh, what is subsoil? The soil that you see, it has got the topsoil. Topsoil is something that is visually perceivable by us. The layer of the, or the region of the soil below that, maybe after a few centimeters depth, the soil which is present, which has got larger particles, larger materials, that is subsoil. Okay. Mass movement slide, Tarun. Okay. And loose materials mean anything which is free to move. For example, in a soil, in a sloping region, if you have soil where there are no plants, that soil is free to move, isn't it? That is loose material. Solifluction is not very slow. It can happen very quickly, but generally it is not as fast as a slide. Creep is not understood. Okay, creep is a very slow movement where very slowly on a monthly or an yearly basis, on a weekly basis, you will observe slight movement down the slope where the slope is not very steep, the slope is gentle. So, ever so slowly, because the water availability is also less, ever so slowly, the soil keeps on slipping down. That is what is referred to as creep. Okay. Do the types of rocks also play a role in this? Obviously, when you have loose rocks, sedimentary rocks, they will get broken easily. They will move easily. Landslide and subsidence is the same? Absolutely not. They are very different. How the subsoil get frozen while upper soil is still not frozen? So you are looking at it in an opposite manner. So there are regions on the planet, especially the polar areas and the Arctic region, where if you consider this to be the entire horizon of the soil, entirety of the horizon is frozen. During the summer season, it is the top layer which defreezes because of rising temperature. Maybe the temperature can go 5 degrees, 6 degrees Celsius. So the top soil will get defrozen for a brief period. And again, during the winter season, it will refreeze. But the bottom portion remains frozen throughout the year. Okay. Can we say a creep is a slow landslide? Please don't say that. Can't connect reason of biological for growing of plants. What do you want to understand in biological growing of plants? If in a crack the plant develops or a plant starts growing, the plant will have its roots extending through the cracks. And in many of the cases, those roots will further lead to the weakening of the rock structure as they keep on exploring the cracks. And that can initiate the expansion of the crack in many of the cases as more plants will come into that region. That will lead to weathering. That is biological weathering. Is that understood? No thawing in permafrost. That is dependent on climate. Whether thawing will happen or not, that is basically dependent on climate. Adnan, we can take example of glaciers. No, my dear friend. Third point in this slide not understood. Earthquake, shaking, and other factors are called can also induce landslides underwater. These landslides are called submarine landslides. So, is it this portion which you have not understood? Okay, fair enough. Understand this. Here, let's suppose there is a sea. Let's suppose, right? Now, this is what is also sometimes referred to as the continental slope, which we'll talk about it in the portion of oceanography. Now, in this case, let's suppose there is a lot of loose materials, obviously. There is significant amount of earthquake. Earthquake means shaking of the ground. Now, that shaking of the ground can lead to these materials sliding. Why? Because these are loose materials, they can always slide down. Lot of sediments, lot of sand particle, muddy materials, ooze, all of that slides down. That is what is submarine landslide or underwater landslide. Is that understood now? Good. So now, mass movement is happening because of gravity? Yes. Right? Good. Now, after this, we come to the portion of gradation. Gradation is a process which includes a combined activity of erosion, transportation, and then deposition. Together, that is what is referred to as gradation. So, when we talk about gradation, it includes three components: degradation, where a particular material is eroded, transportation of those eroded materials, and eventually aggradation or deposition. Now, here, what is the controlling factor or what is the contributing factor behind erosion, deposition, and transportation? It is the agent of nature. And these agents of nature, they basically, depending upon their speed, they have their own carrying capacity. When the river moves with a very significant speed, it will be able to carry a lot of materials along with it. When the wind blows with a very significant speed, it will be able to carry a lot of materials along with it. And as the speed reduces, its carrying capacity will also reduce. And when the speed reduces furthermore, it will start dropping materials. It will start deposition. So basically, carrying capacity of an agent of nature that is directly proportional to the speed. Always remember this. So, if the speed of any agent of nature is high, it will be able to carry lot of materials. If the speed is slow, it will start depositing the material. That is why, in case of rivers, let's suppose you have not observed this, even though we will take the references of rivers when they are very fast. Wind is something that you have observed. All of us have observed winds in our life. Now, you would recall that when the wind is very strong, when the wind is very fast, what do you experience? That the wind will be able to carry anything and everything along with it. In the case of tornadoes, where the wind speed oftentimes, or tornadoes are something not experienced in India, let's take the case of cyclones. Now, in the case of cyclones, when you have the wind speed close to around 200 and in certain cases even 220 to 40 kilometer per hour, you would have observed that that cyclonic wind is able to carry larger objects. Many of the times, the kacha roofs of the muddy houses, the mud houses, they are also carried by the wind. But the same wind, eventually, when they get slower, they will drop those materials. Same is the case with the river, same is the case with the glacier, same is the case with the wind and the sea waves. So, faster the movement of any agent of nature, greater will be its carrying capacity. And for larger distance, it will carry those materials. As soon as the speed reduces, it will start dropping them, it will start depositing them. So here you have these agents of gradation. Let us address each one of them. Let us understand each one of them, and we will take a look at the various different types of landforms created by each one of them. We'll be starting with the running water. That when a water flows or moves in a kind of a river, then what are the events unfolded? Now, in this case of running water, if you observe here, first of all, we'll take a look at the stages of river movement, and then we will address the landforms formed by the running water or a river. Now, stages of river movement. So, river, generally, any river that you take a look into, they will originate from a greater altitude. Maybe due to melting of snow and glacier, maybe due to excessive concentrated rainfall in certain cases, but almost all the rivers, they end up originating from a height, from an altitude. Then they come down the slope, and then eventually they will go and meet the sea or their exit point. Now, accordingly, the river movement and the flow of the river can be classified into different stages. So you have what is referred to as the upper course, the middle course, and the lower course. What is also referred to as a youthful stage. Then you have the mature stage, and eventually you have the old stage. Now, in the case of the youthful stage, that is the upper course of the river. That is where the river is originating from a greater height. The river is actually originating maybe from top of the mountain or the slopes of the mountain. Now, as that river comes down the slope of the mountain, if ever you have witnessed or noticed the flow of the river, now, especially in the mountainous area, what do you think is the speed of the river? Will it be high? Will it be low? As simple as it gets. What do you think when the river hurtles down the slope? Very, very high, correct? Now, if you have ever observed a river in the mountain, is it very wide or is it narrow? What have you observed? The river in the mountainous region, will it be very wide or will it be narrow? Perfect. It will be narrow, very, very narrow. But the river will be deep, significantly deeper. Right? So here in the youthful stage, because of the slope gradient, because of the influence of the gravity, the speed is very high. Speed is very, very high. Now, the width of the river won't be very significant. river will be narrow, but then the river will be deeper, right? In the mountainous regions, that is why you are always advised, anyways, in the case of the rivers, you are never advised to play with the depth of the river, but in the mountainous regions, it can get very deep very suddenly. So here, the river carries out vertical erosion, where the deepening of the river takes place. So here you will observe narrow, observe here the cross-sectional profile. The river will be narrow but deeper. Now, if the speed is very high, so that means carrying capacity will be very high. So the level of erosion, the amount of erosion carried by the rivers in the youthful stage in the upper course will be very significantly higher. Erosion is very high. Now, mostly the erosion which will be carried out, that will be vertical erosion, where it will hit the ground with significant amount of force and it will go deeper and deeper. As the river, imagine as it is coming down the slope, the river will have no interest, or the water will have no interest to expand, because eventually gravity is pulling it down. And while it is hitting the ground, it will hit the ground with so much amount of force that the deepening will take place. So that is why you have deeper and narrow river. So you have erosion, and that too vertical erosion. Okay. So in this stage, mostly you have erosional landforms which are created, very odd, or only one individual depositional feature you will observe in the upper course, but mostly depositional features is something that you will observe to get created. Valleys, gorges, waterfalls, all of them will be a common factor. Then you have the, just imagine this with the analogy of, that is why the name is given youthful, mature, and old. And now imagine it with the analysis or an analogy of human life as well. When you are young, in the early ages, in now recall what your behavior was when you were in your teens, or if you are in your teens right now, imagine what your behavior was in the early part of your teens, right? So in your teenage years, what do you have? Lot of energy, lack of direction. We don't know where to spend our energy, but I have a lot of energy, lot of impatience, right? So that is exhibited by the river as well. That is where the river will move in any kind of direction that it wants. It doesn't have got a predetermined flow pattern, but it will carry on moving with a significant amount of speed, hammering into the depths, right? That is the youthful stage. Then when we talk about the mature stage, it is a different matter that in our lives, even if generally a 10-year-old kid will say that I am now much more mature than what I was when I was 6 years old, and a 15-year-old also considers themselves mature. But in general, when maturity comes, what is there as a common attribute in life? You will observe there's a kind of a directionality. You will observe there's a kind of a stillness. There's a kind of a stability associated with the flow of thoughts as well. Similarly, in the case of the river, when the mature stage comes, the slope has reduced already. So the speed will also reduce. Now the river will be in slight control. So here, slower speed. Now, when the speed slows down, immediately deposition will be initiated. Earlier, deposition was not happening, not significantly. Now, deposition will also be initiated. So, in this stage, deposition will be initiated. But the speed is still significant. It is not as if the speed has died down. You still have energy. And that means erosion will happen. But here you will find that the river, when you observe the river in the plains, any river that you consider, any of the river that you would have witnessed, in the plains, the river gets wider. It gets very, very wide, isn't it? So there is a kind of a horizontal widening of the river. In the case of the youthful stage, you had a vertical deepening of the river. Here you have a horizontal widening of the river because that horizontal erosion is carried out. Because earlier the speed was significant and it was falling down under the influence of gravity, so it was getting deepened and deepened. But now that falling down is not happening, it is moving with a slighter speed. So that is why the widening of the river will take place. So here you have wider river because of horizontal erosion or lateral erosion as it is referred to. Then you have the old stage of river movement. Now this mature stage is also what is referred to as the middle course of the river movement. Now we come across to the lower course, right before the river meets the sea, right before the river enters the sea. So that is what is also referred to as the old stage. Now, at an older age, generally, if you again provide an analogy with the life of humans or anything, what is the energy level? Almost absent. What is the probability of movement? Very, very low, isn't it? So here, the speed is very slow. Very slow speed. No erosion, but maximum deposition. And then you will observe only depositional features. Okay, so that is basically the aspect of the various different stages that you will encounter in any kind of river movement that you will observe. These are the various different stages that you encounter. Nasir, but in steeper slopes, we see there is less depth or less thickness of water. So that is where you have a kind of a smaller stream that you are encountering, or where the water is flowing almost like this. But if you have a kind of a considerable slope, think about it. If ever you have been to, let's say, the region of Rishikesh or in the region of Himachal, where you would have seen river Satluj, river Chenab flowing, there you will find that as long as there is a gradient, the river depth is very significant. Okay, river depth is very, very significant. And understand the logic. It is not some random thought that we are putting into place. The logic is very simple here, guys. If the slope is like this and the river is moving here, the influence of gravity will have a downward effect and the downward movement as well. The river will immediately be following like this. It will hit the base and then the base will force it upwards. That is why in the mountainous areas you come across so many different rapids, because it hits the base, is thrown upwards. Now every time that it does so, the base is deepened, the base is further deepened. If you ever have gone for whitewater river rafting, which is offered in many different places in India now, you would have experienced that in many of the stretches the river waters go very, very deep. Okay, so that is why you have valley deepening as it is referred to. Okay, now after this, when we talk about, will deposition reduce depth in mature stage? Absolutely yes. Okay, so deposition is what? Okay, how many of us don't know the meaning of deposition? Have you heard about the word deposit? What is deposit? Right? Any of us who are not aware about the term deposition? Deposition is accumulation. When you accumulate something, when something is placed somewhere. Is it the reason why Bhutan producing hydroelectricity? Yes, it is also the reason why India is developing so many hydroelectric projects. Then widening happens because as the speed continues, because there is some slope in the mature stage, the speed continues, but then the deepening doesn't happen. So all that water which is brought about, the large amount of water, the huge amount of water, it will in a way try to flow, try to accommodate itself, and that is why you have the widening of the river channel. Okay, right? Soil which comes down by landslide, is it lose fertility? Are you asking whether that soil will be fertile or not? Because after landslide, a soil which is deposited somewhere, generally it will consist of finer particles, and that will in general be fertile in general. For example, take the case of, all of you would have heard about Joshimat, right? All of you would have heard about the Joshimat tragedy, the Joshimat sinking of the land, subsidence of the land. Now, the entire region of Joshimat in itself is actually based upon a large landslide deposit which happened many hundreds and thousands of years ago. So around all this, around the region of Joshimat, if ever you have been to Joshimat, you will appreciate that particular reality much more. Around Joshimat, you will find the high altitude mountains which are there. So a long time back, lot of various different rock particles, including the various lighter rocks along with the soil, that came down as a landslide. So you had all these mountains. From that, landslide happened, and that landslide deposited itself. It consisted of soil, loose soil. It consisted of loose fragments of unconsolidated rock without any structure, and on top of that, a lot of soil as well. All of them as a result of landslide. Now, that is why Joshimat is subsiding and has subsided, because in this kind of a creation, if you put in lot of weight on this kind of material, what will happen? A material which has got lot of sand, lot of soil, loose soil, lot of rocks, if you put in lot of weight, what will happen? It will simply give way, isn't it? So here, because of endless amount of construction which is happening, which has happened in Joshimat, along with the fact that this is a region which sometimes experiences extraordinary amount of rainfall, along with the fact that because of the NTPC's Vishnugarh Tapovan project, you have the diversion of the river streams, and those river streams, they provide the availability of water in that soil as well. What will happen? That soil will simply give way. So that is what has happened, and the land is sinking down. The land is basically sinking down as this land is sliding away. So imagine a kind of a mound of mud that you have created. Try to sit on that mound of mud, because considered your weight, that mound of mud will be almost inconsequential. So consider yourself, or you imposing yourself on that mound of mud. That mound of mud will part way, right? And you will start sinking. Something very similar is happening in Joshimat. So that is what happens when you have landslide materials. But in general, whenever you have landslide and the materials accumulate, there, agriculture is not something which is a common phenomena. There will be vegetation growth which will happen, but agriculture, when you talk about fertility, you talk about in the perspective of agriculture. So that is not a very common phenomena. Okay. What happens after old stage? The river meets the sea, or the river eventually will meet into, or that is the end of the river. It will eventually evaporate in certain cases, or in majority of the cases, 99.9% of the cases, it will meet the sea. Okay. Now, after this, we analyze the various different landforms which are developed by running water. That is the river water. These are what are also referred to as fluvial landforms. Okay, these are what are also referred to as fluvial landforms. Now here you can see a host of landforms created by erosion and a host of landforms created by deposition as well. Now, as we have already seen, almost all these erosional landforms, they are created in the youthful stage. Youthful stage. Only two of the erosional landforms are such which get created in the mature stage. Okay? Whereas almost all the depositional landforms that you will see, they will get created in the late mature or old stage. Okay, is the color of pen visible to everyone or do we need to change this? I think yellow is a color visible to everyone, right? So Tanmay, it is visible to everyone. You are the only one who is asking for that change. Okay. So here, most of the depositional landforms you will find that it exists in the late mature or in the older stage. Only alluvial fans is one of those which occurs in the youthful stage. So Tanmay, your peers are recommending you to refresh the page. Do that. Now here, we will take a look at each of these landforms and how they get created. Here, visualization is something which is very important, where you need to be able to imagine the forces of the movement of the river. See, ideally, all these take place in such a large amount of time that you don't have a CCTV camera which can capture the entire recording of how that landform has been created. This is obviously something which is left to the vagaries of imagination. It is the mature stage erosional landforms where some significant imagination bit will be required. And for this, I want you to center your attention to the point where we had talked about Epeirogenic forces. In the case of Epeirogenic forces, we had talked about the upliftment or the subsidence of land, right? We had talked about that how the land starts getting uplifted, how the land will get subsided. Now, before taking a break, I will leave you to a particular point of thought. I want you to put your mind into that, and then we'll take a break. So, here, let's suppose this is a large land mass. Let's suppose. Now, let's suppose there is a river which is flowing through here. A river which is flowing through here. Let's suppose it is the mature stage. That means the river doesn't have that much amount of a velocity. Now, imagine if in this particular section of the river, the land is experiencing an upliftment, which is happening at a very, very slow rate. What will happen in that case? The upliftment of the land is happening at a very slow pace, maybe 1 centimeter every 10 years or 1 centimeter every 50 years. Think about it. We'll talk about it after the break. So, here, let's take a break and we'll be back. So, we'll take a break for 15 minutes and then we'll be back. How will the river flow be impacted if the land gets uplifted? Will the river stop moving or will there be no effect at all? Think about it in that parameter. Okay. eroded or moved. And with their difference after some years, it will slow down water flow and cut off. If the lift mass level is over the flow level, then the flow can be affected or stopped. Okay, good. Um, River will change its course. Okay, the flow river water remains same. The uplifted land at the place of the river will get eroded. Good, Priyadarshini. Sayed, maybe slight rise in the water, but overall it will remain impacted according to me. Okay, it leads to old valley floor or flood plain. Hmm. Will erode the uplifted part. Gauri, that is correct. Kambapati will erode the uplifted part. Good. Water will deposit. Hmm. No. Gayatri, fluvial landforms are basically the landforms created by the flow of the river. It will be flowing as the uplifted materials get eroded. Good. So, majorly, most of you have been revolving around the correct answer, and that is about the fact that it will slowly and steadily erode that region. How will it erode? What kind of features will be created? We'll take a look when we talk about the incised or entrenched meanders and the river terraces. Before that, let us first of all concentrate upon the other erosional landforms which get created. And then, is there any resource or deposit of crude oil in India? A lot of resource of crude oil in India is there. Krishna Godavari basin in the region of the Cambay basin, otherwise Ankleshwar region in Gujarat, Digboy area in or the Brahmaputra plains of Assam, then northern portion of Rajasthan and western portion of Rajasthan. So in many of these areas you have the crude oil. But may I ask that from where does that question arise when we talk about the running of river? Bombay High, so continental shelf across, you have that. Okay. So here, let us take a look at few of the erosional landforms getting created. So we'll first of all take a look at valleys, gorges, potholes, and plunge pools, and then we'll take a look at it at the other portion. So first of all, get a visualistic idea about what we refer to or what is it that we are actually addressing when we are talking about a valley or a gorge. So here, if you observe this particular image, this is what is referred to as a valley. In the case of the valley, you will observe that the base is significantly broader. The slope is not very, very steep. Observe the river flow here. The river flow is forming a part of that flow in the valley. Whereas when we talk about a gorge, it is not a gorge, by the way. Many of you have the pronunciation as George. It is not a gorge, it is a gorge. So in the case of a gorge, you will get a steeper portion, almost vertical wall-like section will be created. So overall, when we talk about the valley, valley will represent a kind of a feature like this. No, this is not the Riyasi bridge. No, the Chenab, it is not the Chenab bridge. So here, the valley will be created like this. And then when we talk about the gorge, gorge will have a feature like this. Okay. So gorge will have a much significantly vertical wall-like structure with a narrow base, right? So if you take a look at it, valleys are depressed areas of land, scoured and washed out by the conspiring forces. That means a combination of forces such as gravity, water, or in certain cases, even ice. They all take a form of U or V in the case of the shape that we associate. Whereas when we talk about the gorges, they are very deep, narrow valley with very steep sides, vertical sides almost, usually formed by a river or stream cutting through the hard rock. Now, both of these are created by the down cutting action of the river in the youthful stage. So, both of them are created. Both are created by the down cutting. or rather vertical erosion carried by the river in the youthful stage. Okay. Both are created by the vertical down cutting and the vertical erosion. But then their shape is different. So valleys are much broader. The slope is significantly having a gradual slope. It is not very steep. Whereas in a kind of a gorge, the walls are almost vertical. After a long period of time, many of the times, in many of the cases, the gorges they can get converted into valley-like structure. Whenever you have a vertical down cutting, that creates very deep gorges initially. For example, when you have river Indus crisscrossing the Himalayas. Now that river Indus crisscrosses the Himalayas in such a way that in certain areas, the depth of the bottom of the gorge from the surrounding mountain is as much as 5,000 meters. When you have river Brahmaputra creating a gorge as it changes its direction to the southward side at the region of Namcha Barwa, now in the region of the Arunachal Himalayas, that is where it also carves out a very deep gorge, having the side of the gorge, its height is close to around 7,000 meters. So that is where many of the times the gorges created are very, very steep. But then eventually, in certain cases, the gorges can lead to the development of valley. How? By broadening of the base, and also that vertical slope that will get a kind of a gradient due to mass movement. So here, okay, is it clear up till that point, this point of time? Good. Such deep gorges are created by only river forces, no endogenic forces. No, they can be created only by the river action. Okay. So let us take a look at how is it that these gorges can become broader. So this is basically the entire schematic of gorges turning into valleys, into broader valleys. So observe here. Initially, when you have a kind of a gorge-like structure or a kind of what is also sometimes referred to as an eye-shaped valley, so it is very, very, very narrow. Now, over a period of many hundreds and thousands of years, there will be significant amount of weathering of the rocks here. So the side portion that basically gets weathered. So rather than remaining as rocks, they will get broken into smaller fragments, smaller particles, in many of the cases, even soil particles. Now then, aided by the influence of gravity, aided by the other external forces such as availability of water as well, here you will observe sometimes the movement, the large scale mass movement across these slopes. Slowly and steadily, there will be mass movement maybe here, it will fall down, all of that will start getting deposited here, then furthermore it will fall down, it will start getting deposited here, it will get broader and broader, and eventually observe how you have the formation of a kind of a V-shaped valley. Okay, so this is basically when you have a existing movement of the river, and that existing movement of the river through as the river ends up moving through the central portion where it has carried out the vertical down cutting, that is where it will be moving through, and that is where it will create initially an I-shaped valley or a kind of a gorge. The side portion will get weathered, where the rock will get converted, large rocks will get converted into smaller fragments, which are ready to slide down. Okay, I hope this is understood. Why is the river in between? It should fall from upwards. Okay. Why does weathering occur only in the area close to the vertical? Weathering will occur everywhere, my dear friend. Weathering will occur here also. Weathering will occur here also. But it is here where the mass movement will be observed. Okay, for few of you who are unable to imagine the portion of vertical down cutting itself, let me recreate a diagram. I thought I'll need to recreate a diagram for incised meanders. But let us talk about down cutting then. How is it that down cutting happens? Or the downward vertical erosion, how is it that it happens? So let's suppose you have a mountainous area consisting of a lot of mountains in the region. Okay, let's assume this is a kind of a mountainous region. Now, here there is a slope. Initially, if ever you have been to a mountainous area, again, I will repeat the same thing. If till now in your life you have never visited a mountainous area, high time in your life, you have enough time right now, go visit a mountainous area, at least observe what a mountain looks like. Other than the movies, the Bollywood movies that you have seen in the movies, what a mountain looks like, it is important to understand the local topography of how a mountainous region appears to look like. So basically, it will have a kind of a slope. Let's suppose this region will have a kind of a slope before forming a kind of a plain region. So this region of slope that can extend for hundreds of kilometers, even thousands of kilometers for that matter. So here, assume a river is following down these slopes. A river has originated high up in the mountains. It is coming down with significant amount of velocity and it is falling down the slope here. This is where you have the plain region. Of plains. Okay, this is the region of slope. Okay, now let's assume that the river is coming down the slope, hurtling down the slope here. Now, as it is coming down the slope, will it have speed? It will have a lot of speed. Now, in this region, it is encountering the hard rocks. So, what will this lead to? Here, this river will get deeper and deeper and deeper. If you have to think about the cross section, just to give you a visual idea about the cross section, this is a region where you have significant thickness in terms of cross section, and then eventually you come to the region of the plains. So here, when we talk about the river hurtling down the slopes in this area, the river will get deeper and deeper, isn't it? So that is what is referred to as downward erosion. Is that understood? It is here where you will observe downward erosion or vertical erosion. Is that understood? Yes or no? Gauri, is that understood? Tahir, what is it that you have not understood here? And Lakshmi, please let me know what is it that you have not understood in this particular portion. So here, basically, as the river comes down the slope with significant speed, it will deepen. It will go deeper. That is where you have the stage where in these regions, let's represent this as 1. So that will be your this particular portion. So that is why, as it will get deeper, that is when you come across a scenario where you observe this kind of a feature, where through the slope as the river is flowing, you can observe the mountainous area in this picture, and then you observe the sloping area. So it is basically here that you have the vertical down cutting. It will continue to vertically erode that particular area. Okay, as long as it reaches the sea level, it will continue to vertically erode that region because of the significant amount of speed and significant amount of force that it basically accrues. Okay, why Ganges take a peculiar bend? Okay, first of all, address this particular portion, then you talk about any other doubts. Is this portion clear? This means valleys were earlier gorges. Yes, majority of them. Can't these gorges occur due to tensional forces creating horsts and graben? Sometimes you have the creation of rift valley, not the creation of gorges. Okay. Examples of main gorges and valleys important for exam? No. Rivers in Himalayas, they end up creating gorges in general. Yes. Rakshit, in the area of Dev Prayag, where two rivers meet, Alaknanda and Bhagirathi, one stream have clear water and other have muddy water. Yes, that is because of erosion. In short, cutting of rocks by river flow. Yes, as simple as that. Block mountains can be referenced as gorge? Absolutely not. Uni, kindly pay attention to the class. You will understand. Otherwise, you will continue to leave comments here that nobody is actually bothered about. Pay attention to the session. Maybe you understand something. If you don't understand something, ask a doubt. But otherwise, please don't spoil the chat section. Manam, still we are in 5th module? Absolutely, yes, my dear friend. We are still in 5th module. With the speed that we are moving, you cannot expect suddenly that we'll be in 10th module, but don't worry. We will cover the session. The point here that you should be extracting is, have you understood or not? Okay. Why mountains in northeast area take a bend? Again, we will cover those portions in Indian geography, my dear friend. If there is a doubt in this particular area, please let me know. Okay. Erosion is the removal of materials from one particular region. Okay. So that is how the gorge is created, and that is how the valleys are created. Many of the times it is the gorge and the widening of the gorge. How is it that the widening of the gorge takes place? That is also that we have seen. Widening of the gorge will take place due to weathering and mass movements, which will be initiated on the vertical wall section. So in a way, you can imagine that eventually it is these areas of rocks that you see that will start falling after the weathering action. It is these areas of the rocks. Observe here, already the slope has been created, whereas in this portion there is still some verticality associated. So that is how slowly and steadily it will get broader. The river also will erode in the surrounding region somewhat, and that is how eventually you will have a creation of valley like structure. Okay, now then after this, we come to the portion of other erosional feature, and that is what we refer to as potholes. Potholes. Now, potholes, believe it or not, is a natural feature, natural geographic landform which is created by a river. It is a different matter that we encounter these potholes as soon as we step out on the road. In majority of our cities, the roads also will give you the idea about what these geographical features are. But they initially or ideally in the nature, they are found in the youthful phase of the river movement. Let us understand how is it that this is created. So when we talk about in this particular region, let's suppose in the youthful stage of the river, movement. So there is a slope. Then add to the fact here the river is moving with a significant amount of force, with a significant amount of velocity as well. Okay. Now, when the river is moving with a force and velocity, that river will be able to carry significant rocks, debris, small pebbles also. Now, when a river drags a large rock or a large boulder, how is it that it will move? The rocks and the large rock parts, they are heavier. It is not as if they will be floating on the surface. So they will be dragged by the river. How? So they will move. First of all, they will hit the riverbed here. Then they will toggle. They will then hit the riverbed here. Then again, they will end up hitting the riverbed here. Then again, maybe they will hit the riverbed here. So as this rock ends up moving and hitting the riverbed continuously, this rock might also get broken up into small fragments. And other than that, you might also observe on the riverbed creation of very minor depressions like this. Creation of very minor depressions like this. Now, imagine a next larger rock which is being carried. Now, it is the flow or the turbulence of water which will automatically drag the rock near the, or even in surrounding regions it might happen. But if another rock hits the same region, and let's suppose another rock hits the same region, what will happen? It will get deeper ever so slightly. So eventually on the riverbed, you will observe these small indentions, these small depressions. These are what are referred to as potholes. Okay, that is what we ascribe as potholes. So they are circular depressions formed due to stream erosion aided by the abrasion of the rock fragments. Abrasion means as the rock hits, it will get broken into small fragments. As it further rolls and hits, again it will get broken into multiple smaller fragments. So that is what we refer to as potholes. Now, we also have what is referred to as plunge pools, again created in the youthful stage of the river movement itself. So when we talk about plunge pools, now, why are they created? Where are they created? So generally, you will observe the plunge pools to be created at the base of the waterfall. Let's suppose this is a waterfall or a region of a waterfall. Now, how is it that the river will behave in this area? So if in this region, if you have a flow of a river, significant flow of the river, let's assume. Now this river, as you would have observed in the case of a waterfall, this river will fall here. Right? And then eventually the water will start flowing. That is what you observe in the case of a waterfall. But as this water is consistently falling here, this water will create some pressure here at the base where it is falling. It will erode the materials there ever so slightly. Eventually, the repeated action of the fall of the water from the waterfall, it deepens that portion quite significantly. And this forms what is referred to as a plunge pool. Okay. That is what forms a plunge pool. That is why whenever you go to visit a waterfall, it is always advised that please don't go underneath the waterfall or the region where the water is falling don't go there directly. It is a different matter altogether that here, particularly in our country, we have a norm that wherever we find a restricted area, we have an urge that, okay, if they are telling us not to go there, we will go there. That is a bucket list item. Whether we do anything or not, one of the aim is we will go there because it is restricted. Every year, hundreds of lives are lost at the base of these waterfalls in these plunge pools because they are so very dangerous. Because as an individual, if let's say you are standing here, let's suppose as an individual you are standing here, the water level even might be below the level of your knee length. Also water must not be there. Slowly as you walk towards the base, suddenly the water level will get so very deep, it might be above your head high as well. And then the additional force of the falling water won't allow you to emerge on the surface easily unless and until you are a very good swimmer for that matter. So that is why plunge pools are one of the most dangerous regions. It is the basic formation and the falling of the water which creates that depression on the land surface. Okay. Now, here, that is how the plunge pool is created, by the impact of the water which is falling. Now we have the case of incised meanders and river terraces. So when we talk about the incised meander, or even in the case of river terraces, both of them, they will be created in the mature stage of the river. Both of them in the mature stage of the river. Now in the mature stage of the river, when is it that you will observe an erosional landform? Whenever you have the uplift of the land mass. Upliftment of the landmass. In that case, of the landmass. Now, as I told you earlier, in the earlier scenario that we talked about, let's suppose we have this as the landmass. Now, in between that landmass, the entire landmass is not experiencing any upliftment. But let's suppose there is an upliftment experienced in this area in particular. What will happen? You will observe that this region, as it starts getting raised up, as this region starts rising up, what do you experience there? You will basically observe that the river will continue to flow, and in the river bed, that will also experience an upliftment. The river bed will get uplifted maybe by 1 centimeter, maybe by 1 millimeter. All around it, the land is getting uplifted by maybe 1 centimeter. For the river bed, that will be a kind of an obstruction or an obstacle that the river can easily erode. So the river will continue its flow. But all around it, there will be no such erosional method or no such erosional process which will happen. So any upliftment which is observed on the riverbed, the river will be able to erode that. But around it, the upliftment will continue. Isn't it? So here you will observe that riverbed is eroded, or any upraised portion on the riverbed is eroded, while the remaining areas continue to rise up. Okay. So if the rate of erosion, rate of upliftment is very slow, then the river will be able to erode any kind of obstacle that comes into the riverbed. But in the surrounding region, there is no such erosional power. So eventually, it will create a kind of a landform, which we refer to as incised meander. What is a meander? You would have observed or heard it in your English conversation or in your English language as well, that there is a meandering path. That means something which is not straight, something which has got a kind of a wavy nature. That is what you associate with a kind of a meander, isn't it? So here, when you have a kind of a meander, basically in this region, meander is always experienced in the case of a river in the mature stage. But in the mature stage, when the land starts uplifting, the river maintains its original course, whereas the surrounding region starts getting uplifted, and you have creation of a landform which appears to look somewhat like this. So this is what is the incised meander. So observe here, the river is moving at the same height where or at the same level where it always has. But the surrounding landmass has suddenly gotten uplifted. In fact, by studying this particular image in slightly greater detail, you would also be able to identify that in what particular stages the river has been or the land has experienced an uplift. For example, if you observe here, there is a kind of a vertical wall-like section in this region. That means all that upliftment would have happened continuously. Whereas if you observe here, you will observe a kind of a sloping structure. Means this has happened in multiple phases. And that is what is indicated by these lines that you see. These lines that you observe, I hope you are able to see on your screen. These lines that you see. That means at one point of time, this particular region would have been at this depth where the river is moving right now. So it would have been uplifted slowly and steadily. The river would have widened its course, and eventually, this is where a continuous uplift would have been experienced. That is why a vertical sidewall. So many of the times, just by taking a look at the landmass, you can basically come to a conclusion about how that landmass or what are the forces that that landmass would have experienced overall. Okay, so that is your incised meander. Meander is what? Meander is a kind of a wavy pattern of a river movement. That is a meander, generally found in the mature stage of the river. When does it get incised? What is the meaning of incised? Do we know the meaning of incised, guys? Incised means something which has been entrenched there, something which has been put there. So it gives you an appearance as if someone has artificially put the meandering region in that area. Okay, so that is why it is referred to as incised meander. Incised means incision. Incised is derived from the term incision, when you make a kind of a cut, right? So now, other feature that you will observe, that is sometimes observed in the region of Chota Nagpur Plateau, the older areas. It is the older areas which have gone through, older areas of the planet which have gone through multiple phases of uplift and down cutting as well. So that is what leads to the formation of river terraces. This is also an erosional feature found in the erosional feature found in the in mature stage and also here created, just like in the earlier case, created due to uplift of the landmass. Movement of landmass. So You have to be able to visualize this. Let us understand. This is where the river would be flowing. And here on the sides of it, you have a terrace-like feature. Each of these terraces indicate various different phases of upliftment that this region would have gone through. So if you can imagine this, I will try my level best to be able to depict it with the help of the diagram. But understand, I will also have my limitation in drawing the image. So please bear with me. So let's suppose in an area, you have a kind of a region, a landscape, somewhat like this, let's suppose. And this is where it is a mature stage. So mature stage means the river will be flowing like this. Okay, maybe like this. Maybe after a few hundred years, the river would have been flowing even here, would have taken a shape like this as well, maybe. Maybe it would have taken a shape somewhat like this also. So in that entire region, the river would have carried its deposits, erosion, everything, because it is in a mature stage. Now let's assume that this particular landmass goes through a phase of upliftment. Now when the upliftment happens, again the same logic that you have applied in the portion of entrenched or incised meander, that the river will continue to flow in the same level and the surrounding land areas start getting uplifted. Why isn't it that the river gets uplifted? First of all, the river can't get uplifted because river is flowing at a particular level already. And secondly, the any kind of elevation that will happen on the river bed, the river will be able to erode it very easily. So here what you will observe is that, let's suppose there is an upliftment happening. So after some time, you will have or you will observe a creation, existence of a landmass or creation of a landmass which has been uplifted. Whereas the riverbed, the river will continue to move where it is. Okay. The river will continue its movement where it is. So, you will observe a kind of a landmass somewhat like this. And the river is moving here in this area. Now, the river is in mature stage overall. So the river will go for widening. Many of the times it will change its course as well. If it is flowing here, maybe after a few hundred years it is flowing here, maybe after a few hundred years it is flowing through this region. So that is where some amount of widening will take place. And how that widening will appear to look like? You will observe this being developed into a feature which is much wider, much broader. Upliftment is happening because of the epeirogenic forces, my dear friend. That is what we had discussed. Epeirogenic forces lead to upliftment. Vertical upliftment is happening due to epeirogenic forces. Is that understood? Anyone having any doubt that why the land is getting uplifted without any notice, without any government norms or without any regulation, why is the land getting uplifted? So upliftment is happening because of the endogenic forces, and endogenic forces are the forces acting in the interior, and that is initiated by the residual heat, what we refer to as epeirogenic. Okay. So here, eventually you will have a situation where the river is basically flowing, let's say, like this. It has broadened that region. Now let's suppose after this, there is another stage of upliftment which happens. Again, why will the upliftment happen? Because of endogenic forces. Epeirogenic means what? Vertical rise and fall of the land. That is epeirogenic. So here again, there is, let's suppose, another phase of upliftment. So how will that upliftment look like? So the older portion, is something which has already been uplifted, which will go through another phase of upliftment, whereas the newer portion that will basically experience another phase of upliftment. So what you have as a structure which is evolving is what? A step-like feature, isn't it? A kind of a step-like feature is evolving here, right? A staircase-like feature. So here, the river will be moving at the base here. In this region, the river is moving at the base. There also some amount of widening will take place. Again, another phase of upliftment will happen. So this is what is referred to as a river terrace. When you have development of a step-like feature on the sides of the river bank, that is what is referred to as river terraces. They are to be found in the Chota Nagpur Plateau region in India in significant quantities because it is the Chota Nagpur Plateau which has gone through multiple stages of upliftment and subsidence. So example, Chota Nagpur Plateau. I hope now it is understood. Okay. All those who were having doubts about why upliftment and how upliftment can happen, I will take you back to this particular slide where we had talked. Maybe you were not attentive at that point of time. So Epeirogenic forces, which is a part of diastrophism, leads to vertical movement of the land. Okay, it is the endogenic force. I hope that is understood now. Now, after this, we come to the portion of the depositional features. How it works, how it works. Are these ideal sites for terrace farming? Not majorly, my dear friend, because these are largely plateau regions. These are largely the areas where you have hard rocks which are present. How it works in the sense, what works how? Show slide of river terrace. This is the slide of river terrace. Are these V-shaped slopes in stair-shaped areas? Yes, that is generally the overall slope topography that you will observe. Upward movement of land, how it happens because of heat. The heat which is provided, recall the portion of the earlier portion of the what we covered under the convection current, where we observed. If it is not clear, look back at the recording of the previous lecture where we had talked about the fact that when you have heat which is provided from the interior, the land can sometimes get uplifted, sometimes can get subsided as well. I hope you guys remember what we had done in the last week, or is that not remembered at all? I hope you remember we had talked about the upward and the downward movement. Good. How is it that how step is created? Step is created basically when you have the river maintaining its own course by eroding any upliftment happening on the riverbed, but all around it there is, so on the riverbed also upliftment will be experienced, but the river will erode that, but all around it will basically keep on rising. After some time, the river will widen its base because it is in a mature stage. It will move horizontally. It will keep on eroding materials. So it will widen its base. Then again, the second phase of upliftment happens. So these portions will also get uplifted, these areas that you see. So that is how eventually step-like feature get created. Okay. I think water caused to digging the land. No, you think wrong here. Water does not cause digging the land because this is in the mature stage. Okay, so it is not, please understand, in case any of you are getting the doubt that it is the water which keeps on deepening here, that is not something which happens. It is the land which rises up. It is not as if the water will keep on going downwards. If that is the case, till where will the water go? Till what level can the water go? So even though it is not required to be studied in the portion of general studies, let me introduce to you to the basic fact. When we talk about the cycle of erosion and the cycle of degradation, Erosion will be carried out only up till the level of the sea level, where the water is going to empty itself. Beyond that, no erosion will happen. Okay, all the erosion that you see in the river, that is happening up till the level of the sea level itself. Okay, and yes, Kulam, that is correct. Why is it in wave pattern? Is there any reason behind it? That is because, see, this is the first stage. This is where, unless and until I write it down, many of us, we don't get that kind of a satisfaction. So I will write it down. So that is, the land gets uplifted on all sides. But the river continues its flow as it is able to erode any kind of upliftment on the riverbed. On the riverbed. Then here the river widens the base region by method of erosion. Okay. Then second phase of upliftment happens further elevating the earlier raised portion. This creates a step-like feature. Step-like feature. Is that understood now? Okay. Is that understood now? Good. Now we come across the depositional features and the depositional landforms which get created. So you have a variety of depositional landforms, and deposition is created or carried out when the speed reduces. So as the reduction of speed happens, that is where you will have the reduction in the carrying capacity as well. And that is where deposition will be initiated. Majority of the depositional features that you come across, be it meanders, floodplains, natural levees, oxbow lakes, braided channels, deltas, all of them are created in the old or the late mature stage. Or late mature stage. So here, basically, it is at this stage that the speed will reduce and deposition will happen. This is what is created in the youthful stage. Now, when we talk about a floodplain, so what is a floodplain? So basically, if you observe a kind of a river channel, the cross section of a river channel, how does the cross section of a river channel appear to look like? So the river channel, if ever you have visited a river channel or a river in general, not by the bridges that you cross. It is not as if that I was traveling by train, I crossed the river and I visited the river channel. No, if you have actually walked up to a river, you will observe that there is a gentle gradient leading you towards the region of the river. There's a very gentle and shallow gradient. And here is where the river water will be. This is what is the river channel. Now, under normal circumstances, this is where the river will be flowing. But let's suppose there is a kind of a flood. So if there is a kind of a flood, the river will have a kind of a flow even in these areas. When the region floods, now the river consistently carries a lot of fine particles which we refer to as silt. And those silt will be deposited by the river wherever the river flows. So during the floods, all the region which is covered by water, in all that area, silt will be deposited. In all this region, you will have deposition of materials which will be experienced. Right? Deposition of materials will happen. And this deposited region, which has got deposits carried out by the river, eventually the flood waters will recede. Eventually, the river will come to its own natural flow, but then it will leave behind these deposits. And these deposits, which are carried out, that is what you refer to as the floodplain of the river. Okay, that is what is referred to as the floodplain of a particular river. Now, as the river flows, it will bring a lot of these silts and sediment, lot of these deposited material. Now, a lot of this deposited material, they will start getting deposited on the sides here. As it flows, the river will keep on accumulating the deposits on its sides. Slowly and steadily, this will accumulate in a kind of a height. So if you would have observed, when you go to a river, when you actually approach a river bank, you would have observed that the height increases ever so slightly, and then there is a kind of a dip leading to the river. If you have never noticed it, notice it even now. Wherever you get an opportunity, you will observe that as you are walking towards the river, there is a kind of a slope. But immediately as you approach the water, there's a slight upliftment, and then you have the region where the water is. So this upliftment is also created by the deposits of the river. As the river is moving consistently, it will deposit materials on the sides. This is what is referred to as natural levees. Levees. Okay, so these are also basically created as a result of the process of deposition. Just like in the case of floodplains, these are also created by depositional feature. Now let us analyze few of the other depositional features, starting with the alluvial fans. This is amongst the only depositional feature that you will find in the youthful stage of the river action. So this is in youthful stage, erosion is observed. Deposition is not very common. So this is a top view of that region. And understand this with the help of a frontal view as well. So basically, if let's say you have a mountainous area, let's assume, okay, let's assume you have a region of the mountains. Now, if a river is coming down the slope, it is going to come down the slope with a significant amount of velocity, significant amount of speed, isn't it? So here, as long as it is coming down the slope, it will carry large particles, large rocks, even large portions of the rocks it will be able to carry, because it has got significant speed and large amount of force. But then As soon as it encounters the plain region, wherever it encounters the plain region, suppose this is the slope where the river is coming like this, and then suddenly it encounters the plain region. What will happen to the speed, first of all? As soon as it encounters the plain area, the speed will reduce tremendously. With the reduction of speed, what will happen? Carrying capacity will drop, and whatever larger particles that the river was carrying, immediately it will get deposited, isn't it? So all the materials that the river was carrying, all the materials which the larger materials which the river was carrying, they will get deposited here, right? And they will get deposited all around the river in general, because it has encountered a kind of a plain region. You will have deposits of the materials in this region. Now, because in majority of the cases, these deposits, in majority of the cases, these deposits, they basically are created in a kind of a traditional fan-like shape. So that is why they are referred to as alluvial fans. And when we talk about fans, please don't take a look at your ceiling. That fan has got three blades. Here is drawing a semicircle. How can we call this a fan? Fan is basically the one which. So this is the traditional shape of the fan. So basically, that is how the deposit. So observe this particular image in specific. So here, when you observe this image, observe how in the mountainous area how narrow that river is. It is coming down, hurtling down the slope, and as it encounters the plain region, this line demarcates the plain area. This is a kind of a satellite view, satellite image. So here, when you observe this, you will observe that the deposits, they are carried out here, isn't it? So this is what this portion of deposit, this is what we refer to as alluvial fan. For example, when river Kosi comes down the slopes, in fact, majority of the Himalayan rivers create a very large alluvial fan. Particularly notorious is river Kosi. When river Kosi comes down the slope, it creates an alluvial fan with a radius of 8 kilometers. Think about it. The radius in itself of that fan will be around 8 kilometers. So that is how huge set of deposits it will end up creating. The green things that you observe, that is the vegetation. As observed from the satellite map, that is how the vegetation looks like. Because in these areas, large boulders and rocks will get deposited, so obviously no vegetation in that area. But beyond that, as the river continues, here you will observe the presence of the trees and so on. Okay? So that is your basically alluvial fan. Yes, larger deposits, they won't be able to move ahead because as the speed reduces, when the river comes on the plains, its carrying capacity will also reduce significantly. Okay. Now, after this, we come across what is referred to as a meander. Now, meander, as I already told you, is an English terminology which talks about the presence of a kind of a wavy pattern, right? Where you don't have a straight line, when you have a kind of a wavy pattern, that is what is a meander. Now, in the mature stage of the river, now meander, by the way, is created both by the action of erosion and deposition. It is not only restricted to erosion, not only restricted to deposition, it is created by the dual action. But when is it that the meander is created? When the speed is slow. So here, what you can do as an experiment is, in whichever room you are sitting in or sleeping in or lying down or standing as of now, now the floor of the room, if it is flatter, if it doesn't have a distinct slope, there you can carry out this experiment. Do one thing, pour some amount of water or small amount of water on the floor. If the floor doesn't have a distinct slope, you'll find that either that water accumulates, right, or tries to navigate in a kind of a wavy pattern. Wherever it will find a slope, it will try to go there. It will find a slope. So that is where, if there is no significant speed, the river meanders. It attains a wavy pattern. How is that attained? So let us understand that. So meander is an erosional cum depositional feature formed by the river in its mature stage. So it is formed when the water flows in a curvy, bendy path like that of a snake. So as the river makes its way through an area that is relatively flat, it oftentimes develops bends as it erodes the path of least resistance. So here, water accumulated, pour some more water. If the land is flat, you will observe it will develop a kind of a flow. Then maybe as you push in more water, that flow might change somewhat. So here, Chandrasekhar, my dear friend, I understand you are pasting the same question again, but let me be very clear that the question that you are asking is not making any sense. So frame it in a better manner, put some attention into the language, and then maybe we will be able to solve that. Why water moving land is not increasing upwards? So that does not make any sense, my dear friend. And I want to be as modest and as polite as possible. Please don't take it in a negative manner. Frame it and then ask it at the end of the session. I will answer you. That is a guarantee. So here, when we talk about it, basically, understand this. So let's suppose the river is flowing like this. Now, overall, basically, you will observe that the river is trying to find a slope. It is flowing at a very tardy, very slow pace. So this river, it will generally, you will observe that the river on the sides, there is a slow movement on the sides of the river. This is something that you would have observed, that the fastest movement of water is where? In the central portion of the river. On the sides it is slower, because that is where it is experiencing some amount of resistance and friction. So here, due to the slower movement, it will start depositing materials in this region. Let's suppose in this particular region, the river has deposited certain materials. Let's suppose certain materials have been deposited. Now, how will the river flow? Think about it. It is simple fluid dynamics. So the river will now flow like this, isn't it? That is how the river will be flowing. So when the river is flowing like this, it will exert a force here. It will also exert a force here. So in these regions, will there be some amount of broadening which will happen? Some amount of widening will happen in these areas. So in these areas, what you experience is that this region will experience some amount of widening. You will have the river flow as somewhat like this. Okay, then what will happen? Then after that, as the river water continues here, it will get diverted like this. Now in this particular portion here, if I mark this portion here, as the river water is getting pushed in this direction, the speed of river here will be fast or will it be slow? What do you think? In the portion that I have marked, this portion that I have marked A, the speed will be slow or fast? Very good, it will be slow. The speed will be fast in this portion, but immediately below it, in these regions, the speed will be slow. Similarly, in this region, the speed will be slower because the river is getting redirected here. So wherever the speed is slow, depositions will be initiated. So you will have depositions here. You will have depositions here. And then all the force of the river is directed in which direction? Here. So in this area, there will be expansion. So like this, eventually, the river will gain a kind of a wavy pattern. And that is referred to as a meander. That is what we refer to as a meandering river. This is what you observe as the meandering river. Okay, so it is observed in the plain region where you don't have a distinct slope and the speed is slower. Sometimes what also happens, as you observe this meander, you will observe that sometimes the river will continue to erode here as it moves and it joins with this particular branch. Now, as the river water joins here, it will follow the shorter route. Why will it follow the longer route? Isn't it? I hope it is making sense. Sometimes what happens is that this river, it erodes in this region and it approaches here. It joins here. So basically what will happen here is that the longer circuitous route that you have, that doesn't get the supply of water anymore because the river develops a shorter path. So that longer path, it gets cut off. And what you are left with is nothing but a kind of a lake. Observe here. This is a part of an older meander which has been cut off as the river has formed a kind of a shorter path on its own. Maybe after some time, the river forms a shorter path even here. So even this portion that you see will be cut off. So that cut off portion of a meander, which resembles a kind of an oxbow, that is what is referred to as Oxbow Lake. So Oxbow Lake is a curved lake formed from a horseshoe bend in a river meander where the main stream has cut across the narrow end and no longer flows across the loop. So it has found a shorter path through which it will flow, and the longer circuitous path gets isolated, gets cut off, and that is what is referred to as an Oxbow Lake. So if you have to represent it by an image, so let's suppose the river flows like that. Let's suppose. Now here, after significant amount of erosion, the river, here also erosion will happen. So eventually the river might develop a shorter path. And once the river develops a shorter path, that longer circuitous path will be cut off. And that is what we refer to as the Oxbow Lake. Okay. So that is basically observed again in the late mature stage of the river. If ever you get an opportunity to move by airplane or fly between Delhi and Kolkata, or let's say Delhi and Bhubaneswar, or Delhi and Raipur, or anywhere across the northern plains of the country, if you observe carefully on the ground, you will observe many such beautiful meanders and many such oxbow lakes getting created. Oxbow lakes generally dry up, but during the rainy season, you will have enough water in the river to form that linkage again. Again, during the dry season, its connectivity will be cut off. So that is basically the formation of meander and oxbow lake. Then we have what we refer to as the braided channels. Do we have meander river in our country? Absolutely, yes. That is what I told you, that all across the plain regions of India, you be it any of the rivers that you consider in the plain regions, they form meanders. They form very large meanders. Okay? Yes, Tahir, that is correct. Speed path of the meander. Vaibhav, understand this. So if a river generally moves slow, that is where deposition will happen. Yes, Nitin, very perfect. Cover Lake. Where is Cover Lake, by the way, Nitin? It is the largest oxbow lake in India. It is also designated as a wetland of importance. Very good. Kanwar Lake is in Bihar. So here, basically, you will observe, let's suppose, Vaibhav, understand this. If this is the river flow and the flow is very slow, the flow will be much slower on the sides. So let's say depositions have happened like this on the side significantly. So the river flow will be channelized across these deposits. And as it will be channelized here, the river water will attack this with some kind of a force. So there will be some expansion here. And again, that will channelize the river like this, right? Just like a flow of water. So this will lead to expansion here as well. That is how you gain a wavy pattern. Vikram, find out the location of cover lake. It is one of the most important wetlands when it comes to migratory species. It is a large oxbow lake. Now, then we have braided channels. So braided channels is derived from the term braids. Now, braids are something that you would observe in the kind of a hairdo, right? Braids. So when you have the river to be flowing in the old age, in the old stage, this is formed in the old stage of the river movement. So when the river is something which flows in the old stage, in that case, what will happen? The river will deposit materials because the speed is very, very slow. So it will start depositing all the materials within the river channel itself, isn't it? So here, in that stage, depositions begin to happen in the river channel itself. Now, if a particular river is flowing and the deposition, so observe this is your river channel. Observe how the depositions have happened within the river channel. So in that case, the streams, they get subdivided into multiple smaller flows. And you won't be able to figure out which is the main stream here. And here, the entire flow is basically inhibited by these multiple streams which are generated. All these that you see are what? All these are nothing but deposits. Okay, so that is how you have the creation of braided channels, generally observed in the old stage when the flow has been reduced quite significantly. Okay, then after that we have the deltas. Deltas are the final depositional feature created by any river at the time when it meets the sea. That is where the deltas are created, or at the place where the river exits itself or exits or empties itself, wherever it empties itself, that is where the deltas will be created. So deltas are your depositional feature. Depositional feature created in the end portion, end stage, while meeting the sea. Okay. Now, in this case, while the river tries to meet to the sea or empty itself into the sea, what will happen to this? Reduce to zero, because on one side you have the force of the sea, on the other side you have the river which is moving. So the speed will be almost reduced significantly to zero. So as a consequence of that, when the speed is reduced to zero, what will happen? Anything and everything will get deposited here, isn't it? Everything will get deposited. So as the materials, they start getting deposited, observe, this is the river, this is the flow of the river, everything. And by the way, what size of particles will get deposited here? You will find very fine particles of deposit, because the larger particles, they would have been deposited much earlier. It is only the finer particles which the river has managed to carry this far. And the finest of the fine particles will eventually indicate a kind of a deposition. And that is what we refer to as a kind of a delta. So deltas are very, very fertile. And deltas, basically, they get replenished. The deposits will get replenished almost every year. So you have various rivers creating a delta. Krishna Godavari deltaic region is very, very fertile. Then you have Mahanadi Delta, Kaveri Delta. Then you have Sundarbans as the largest delta across the world created by river Ganga and Brahmaputra. So that is where, before meeting the sea, that is where the deltas are created. Now you have various different types of delta depending upon the topography of the land and the feature of the sea as well. So you have arcuate, bird foot, all the different types of delta, not required for your general studies. You just need to be aware that how this delta is formed. So how is it formed? As the river water is flowing, when you talk about the sea, that is where it encounters resistance. That is where the speed is zero almost. So anything and everything that it is carrying, it will deposit there itself. That is where you have the creation of deltas. So you have examples. I'm sure you would have read about deltas in your school as well. So when we talk about examples, you have Sundarbans, Krishna Delta, Godavari Delta, Kaveri Delta, and so on. Okay? Delta and alluvial fan is same. How did you reach this conclusion that delta and alluvial fan is same? Obviously, they are not same. One is formed in the youthful stage, other is formed in the end stage. Just because the shape is same does not mean they are the same things, right? Many things are same as per the shape, but they are very, very different. An orange is different from an apple and so on. Now, after this, we come across the landforms developed in the underground region by the action of water. So this is created by the kind of chemical weathering or the chemical erosional process. This kind of underground landform is created by the chemical action of the water, where the water actually dissolves the materials which are soluble in it. For example, the calcium based materials, wherever you have limestone rocks, limestone is very rich in calcium. So if you have in a region lot of those kind of materials, water will keep on dissolving those and create erosional and depositional landforms. This is what is also referred to as karst topography. Why is it referred to as karst topography? That is because these kinds of landforms for the first time was experienced in the karst region of the erstwhile country of Yugoslavia. That is why the name karst topography. Now, in this particular kind of landform is experienced or is something which is witnessed in many parts of the country, be it the region of Meghalaya, where it is very, very dominant around the region of Cherrapunji, be it in the region of even Karnataka, you'll find many of these. So that is where you have these landforms. So how is it created? Where water interacts or reacts with, or rather dissolves materials soluble and creates a cavity or deposit like feature. Okay. Now, which are the materials soluble? Generally, you will find calcium, calcium carbonate, etc., which are soluble. So, understand this. For example, let's suppose this is a region. So, generally observed where the base rocks are rich in calcium, magnesium carbonates, etc. So, generally observed in regions rich in limestone rocks. So basically, observe here, that you have, let's assume this is a kind of a limestone rock formation. Now, initially, there will be significant amount of availability of water. Slowly and steadily, they will start dissolving materials. And that is how eventually, wherever they are able to dissolve the materials available, they will start dissolving them, eventually creating large cavities or sometimes even deposits. So, even this process ends up creating erosional structure which are in a shape of a cavity, ends up creating depositional structures as well. So erosional structure, for example, sinkholes and caves are created, uvalas are created. So how is it that these are created? So basically, think about it. So if this is a landmass, if this is a landform, let's suppose all of that is rich in limestone. So it will basically, what it will do is, all the water which is available, it will start percolating. It will start dissolving materials in a kind of a capillary manner. And eventually, the entire region will experience a dissolution. And what you have is a creation of a cavity like structure. That is a sinkhole. So, if you have to see a sinkhole, observe this. This is a sinkhole. Please don't confuse it with a pothole. Pothole is very small. Pothole, which we have seen in the creation of a river, in a river bed, that is very, very small. Just to give you an idea about how large this size will be, what you observe on the side here, this is a full-fledged highway structure where vehicles can move. What you observe here is again another alternate highway which has been constructed. So these are your large sinkholes. These are very, very large in size, many, many meters wide. Okay, so how is it created? It is created slowly and steadily as the materials they get dissolved and then they basically are taken downwards, right? So basically that is how eventually or initially a sinkhole gets created. Here is your creation of a sinkhole. Now, over a period of time, you would have observed in this image as well, there is a tendency that these sinkholes can get together. These can form a larger body of eroded material, isn't it? There is a chance that this will get together, form a larger hole here. Eventually, it also can get merged here, create a very large structure like this. So, all this creates a very large valley like sink, what is referred to as uvalas. Uvalas are nothing but a combination of many such sinkholes taken together. That is why it is referred to as a valley sink or an uvala. Now, sometimes here the rainwater or maybe the seasonal runoff, all of this, basically, let's suppose it starts dissolving materials. It will continue to dissolve materials here as long as the suitable materials like calcium, etc., are present. They will continue to dissolve materials everywhere and eventually the water will exit somewhere. So, in the process, they will create a very large cavity underground that we refer to as caves. Now, these caves can be many kilometers long, many, many kilometers. If ever you happen to visit the region of Cherrapunji, there you will observe many such cave openings. Thankfully, they have been now closed by the government agencies, and the government doesn't allow you to enter those caves. Because earlier, what used to happen is that these caves, many of the tourists who would venture out there, just because they would have seen multiple movies and because there's a kind of an adrenaline rush, many of them would enter these caves. Now, these caves, they necessarily will not always have an opening. These caves will go as deep and as long as the water is able to dissolve the materials. And maybe that dissolution would have happened for hundreds of years. And one cave might lead to four other caves might lead to 10 other caves. Many of the people, they get lost, never to be found again. If you recall, few years back, there was such an incident in the region of Thailand, where many of the school students who went on a trip into one of these caves, they got stuck there and they got lost there. Eventually, there was an international evacuation rescue mission which was underway to get them out. So that is basically the erosional structure created by the chemical dissolution of water. That is also what is referred to as a karst topography, because all these structures initially were found in the karst region of Yugoslavia, hence the name karst topography. Yes, Kirtana, that is correct. Okay, so that is basically where we will restrict it today. The depositional structure, that is stalactites and stalagmites, we will study tomorrow, and then we will continue. Okay, I hope that you have understood. Now let us take a question here, a couple of questions. Natural levees, Janvi, is basically the deposits which happen immediately on the side of the river channel, the deposits that the river carries along with it, and it keeps on dumping them on the side of the river channel, creating an uprised portion on the banks, that is natural levee. Now, Lakshmi, plunge pools are created at the base of the waterfall, where the force of the water falling, that creates a kind of a depression, that is a plunge pool. Yes, anyone who doesn't have a question, you can leave the session now. Don't worry about it. And Chandrasekhar, okay, in the previous you said that the land is uplifted between the river flow due to convection current. But my question is not why land is not uplifted in the region of the water flow or at the river bed. I hope that is your question, Chandrasekhar, that why at the base of the river doesn't the land get uplifted? So even there the land gets uplifted, my dear friend. But because the rate of upliftment is so slow, that you will find that the river is easily able to erode any obstacle on its riverbed. So if you have to visualize this, let me help you visualize this. So let's suppose this is the land and this is the riverbed. Now, while every region will experience an upliftment, here also there will be an upliftment. But as I told you, the river is flowing. Let's suppose the river is flowing like this, and the upliftment is experienced only in this portion. So as the river continues its flow, the river will experience that in its riverbed, the riverbed has raised by 1 millimeter or maybe 1 centimeter. So imagine a river is flowing with its full might, and the riverbed is upraised by 1 millimeter or 1 centimeter. How much is 1 centimeter? This much. So what will the river do? It will erode it easily, isn't it? So as the river erodes it, it continues to maintain the same height where it is flowing. But all around it, the land, there is nothing to erode the other upliftment which has happened here, here, and so on. So all around it, the land keeps on getting uplifted, and the river continues to erode any upliftment on the river bed. That is why the river is able to maintain that position, whereas the surrounding land keeps on getting uplifted. That is why it is an erosional feature. Okay, I hope that is understood now, Chandrasekhar. Cave formation, basically what is cave formation is that, let's suppose, let me take the case of this particular image. So here the water keeps on dissolving the materials here. It keeps on dissolving, and fresh influx of water through rain, etc., it will continue to dissolve as long as there are available materials which can be dissolved. It will continue the solution process. That is how in the entire process it ends up creating a very large cavity. That is what is a cave. Okay, right? uh Lakshya, those are deposits, those are stalactites and stalagmites, which we'll cover in the next session. And yes, Aishwarya, Yana in Karnataka, a very, very good place to visit. So Yana caves, they are very, very famous, very beautiful places. So there you will find a lot of these. Good one. Vaibhav, every sinkhole has leakages beneath the ground. That is how the sinkholes are created. So this is what will eventually lead to a sinkhole. Maybe the region has all the materials which have been dissolved by water. So that is what will create a sinkhole. As much as the upliftment on the sides of the river, so is the erosion by the river. Nasir, that is correct. That is how you maintain the flow of the river, and the river maintains its level. Okay. Madhuri, I would suggest to you to take a look at the physical map as well. Physical map is where you have the physical features. Mustafa, kindly throw light on my question. I will throw light if I am able to see your question. Uh, Sakshi, how sinkholes are made? Slowly and steadily dissolving the material which are present here. That is how eventually an entire depression is created. After creating cavity, where will the water go? The water can basically flow out from somewhere here as you have the cave openings. You have the various cave openings that will emerge. So many of the times what actually happens is, if you think about the land mass, the land will be somewhat like this. Now, here the water will start eroding. It will create a large cave that is not visible to the naked eye either ways. And the water might exit here, and you will observe a kind of a waterfall. So in many of the regions, you would have observed a kind of a hill-like structure, and water is emerging from between. So there must have been a cavity inside. Okay. And is Ganga youthful or senile stage? So Ganga will have a youthful stage, a mature stage, and also a old stage or senile stage. So Ganga has all the three stages. So it has Godavari, so has got Brahmaputra. Okay. And how does cave result in subduction? Cave will not result in subduction. No. Incised meander you will find in smaller rivers in the region of Chota Nagpur Plateau, Vikram. Yes, Gulam, that is correct. Web development of hydroelectricity projects are one of the reasons for landslide and floods in North India. Absolutely, yes. And that is correct. Sinkholes are formed due to accumulation of materials only, Vivek? No, but because of dissolution of materials. Right? And right. So these caves you would have also come across. Okay. So I guess floodplain. Okay, floodplains are basically the deposits created on the sides of the river for a large distance, where maybe at one point of time the river has been flooded and the river water extended in all that region. The river has flooded and deposited all the materials. So that is what is referred to as a floodplain. Extent of the floodplain varies. In certain cases, it can be few hundred meters. In certain cases, it can be a few kilometers as well. Stalactite and stalagmites, what they are collectively called. They are referred to as the deposition of Karst topography. That is what is a part of the Karst topography. Okay. Vikram, we will have a separate doubt clearing session at the end. That is the 25th session we will have. That will be the doubt clearing session. And natural levees, as I told you, it is basically deposits which are happening continuously as the river flows on the river banks, on the sides of it. It keeps on depositing material. That is natural levees. Right? Stalactite, stalagmite will cover tomorrow. Can we decrease the speed of river at youthful stage? Yes, you can form dams. You can dam the river, but it has got its own environmental damage. Right? Kirtana, I'm unable to look at your doubt. So, does the sinkhole meet cavity? Which cavity are we talking about? Yes, many of the times the sinkholes can lead to a cave, if that is what you are asking. Okay? Right. So that is where we'll end the session here today. We continue from here tomorrow. And I would suggest to you, kindly take a look at the annotations of the PPT and also look at the portions that we are going to cover tomorrow as much as possible. Try to flip through and browse through the PPT. It will make your understanding much better. When tomorrow we approach the portion of climatology, your understanding will be much better. Okay, so that is where we'll restrict the discussion for today. Till we meet again tomorrow, take care of yourself. Goodbye. Have a good night. Thank you.